maybe, excuse me. Is there a problem with my microphone? I get a message.
No, sir, it's absolutely fine. We can hear you.
Okay. Okay, thank you. I get a system warning about something. Didn't read it exactly. Yeah, back to the presentation. So what you may see here is that we have division, for example, between graph-based methods, taxonomy-based methods, and ontology, or the formal resource-based methods in this case. Even though all of those are represented in a graph, this division by knowledge representation considers them to be entirely separate, which is why there is a bit of a mess in this representation. So as I mentioned, in an ontology, we may have labels and descriptions written in natural language. So to a single ontology, we may apply taxonomy-based methods, of course, because it contains taxonomy, graph-based methods, because it is a graph, and ontology-based methods. And on top of that, we may also apply string-based methods, because we have labels and descriptions in strings, and naturally, language-based methods, because those labels and descriptions are written in a natural language. We might also, excuse me, there's something in the background that is bothering me. Okay, back to the presentation. So we may use the same methods for the same knowledge, even though we have the same knowledge, so the result should be the same. The result might also be different because we have a messy classification. So not a very useful in practice way to classify similarity, I would say, but a very granular and might be useful to researchers and computer scientists. Now, an alternative way to classify similarity is by semantics. And semantics, in short, is meaning. You can swap one word for the other. The meaning of similarity. So I would like to point to the two problems that we may encounter in calculating similarity. One is something that I already briefly touched upon, the representation of knowledge. The same knowledge may be represented in different ways. So here on the left side of the slide, we have the same knowledge that Jaipur is the capital of Rajasthan. I apologize for my pronunciation. And the same knowledge is modeled below that natural language sentence in a graph, meaning this graph is equivalent when it comes to knowledge to the sentence above, but the representation of this knowledge is different. And on the technical side, of course, we have different data, so we need to apply different algorithms, different similarity measures to calculate similarity. On the practical side, we might not be interested in how the knowledge is represented if we're trying to calculate similarity. We just want to get the result. And the second problem of calculating similarity is that whenever we need to arrive at a single number, there is a number of information that we might gloss over or number of properties that we skip. On the right side, we have images of faces, well, drawn faces, not actual human faces. And we can clearly distinguish that there are two groups of those images, one on the top and one on the bottom. So we might assume that every face on the top is more similar to another face from that same group than it is to a face on the bottom. On the other side, if we look at those faces from a different point of view, we can find frowning faces both on top and on the bottom. And that is a different kind of similarity. So even though the way, the perspective of those faces is what jumps out at us immediately. So we might consider that the most important factor, the expression on those faces, is also important for calculation of similarity. And the question is, how do we weigh those two? Are both equally important or not? And to answer that question, there is a proposition of applying dimensions of similarity, which is a model of similarity that considers many different aspects of similarity and shifts our attention from the question of how similar two entities are to in what way are they similar and to what extent. So in traditional similarity model, we have our universe of knowledge, so knowledge representation. Then we have the representation of the same knowledge for the purposes of calculating similarity, so our model of similarity. And we may have multiple similarity measures that arrive at a single result. In the dimensional approach, we, in a similar fashion, have our model of knowledge. We move into model of similarity, which we split into multiple universes, just like Marvel did in their superhero movies, to arrive at multiple separate results that are then combined into a dimensional vector. So if you're wondering who did it first, Marvel or the dimensional approach, well, this idea is older than the movies. I'm not sure about the comics, but just to note. So there are many dimensions of similarity, many ways to divide knowledge into dimensions. I will give you the most important or interesting examples in this presentation. So the taxonomic dimension of similarity is simply similarity of types or similarity in a taxonomy. I already described what a taxonomy is, so I will not go deep into that. Notice that similarity of taxonomy doesn't necessarily state that we need to represent this knowledge as a graph. So here we have this sentence, very short one, dolphins are mammals, which may also be described as this short part of the graph without the class chordata. So notice that the same knowledge may be represented in different ways, but what we care about here in the taxonomic dimension of similarity is the similarity of types regardless of how those types are described. And naturally, the similarity of types means that there is some connection between classes. There is some subclassing going on. The descriptive dimension of similarity, contrary to the taxonomic one describes similarity of properties, so something that an entity has as opposed to what it is, which is covered by the taxonomic similarity dimension. So for example, weight, a physical feature, is covered in the descriptive property, descriptive dimension of similarity. So is, in this example, diet, reproduction system, gestation period, coloration, and so on. And any kind of description or property that we add that goes beyond the taxonomic description is covered in the descriptive dimension of similarity. And those two, taxonomic and descriptive, are the most important ones. We may also have subdimensions, descriptive subdimensions, where we assign a specific meaning. We describe our part of the descriptive dimension in a way that is useful to calculation of similarity. So for example, the physical descriptive subdimensions describe properties that are physical. And just like any other descriptive subdimension, not every entity can be expressed or even exists in any given any given descriptive subdimension. So for example, ideas such as computer science or calculation of similarity, those do not have any physical features, so they will not be represented in the physical subdimension of similarity. Therefore, that dimension is not of any use to us if we want to calculate similarity between concepts. On the other hand, any physical entity has some physical features, physical properties. Therefore, we may calculate the physical similarity between those. And the physical subdimension may also be divided into more and more granular, going down to, for example, the dimension of color. If we only care about color, we may also use such a very small and granular physical subdimension of the description dimension of similarity. And in a similar fashion, we may create much more subdimensions. We have examples here given on the slide are, for example, geographical. So the geographical position refers mostly, or would be most useful if we're talking about cities or large entities, large physical entities like cities, rivers, countries, and so on. But when it comes to animals, we may also represent them in the geographical subdimension by considering their habitat. So where in the world we may encounter them, and so on. The number of descriptive subdimensions is only limited by our imagination. The lexical dimension of similarity is useful even in ontology modeling, because often when we describe in our formal and structured ontological knowledge entities that are within our domain of discourse, but philosophically they go outside of it, we have to attach also some written description to explain it, mostly to humans, to ontology engineers, what that entity actually is. So here on the right, we have an example from the SSN ontology, which is the ontology used to describe IoT systems and devices. An actuator, as the description states, is a device that is used by or implements an actuation procedure. Now, this part may easily be modeled, and in fact, it is modeled in the ontology. We have the entity of a procedure, we have the type, additional type actuation procedure, and the relationship of being used by and or implemented by. And this is expressed here in the restrictions part. But if we read the description further, it is something that states that changes the state of the world. Now, technically, we could also create in our ontology an entity for the world and attach the property of being influenced by change coming from the actuator, but that goes beyond our domain. So remember at the beginning, I said that knowledge needs to be contained in a single domain, and modeling an entire world goes beyond our domain of IoT systems. I hope you agree with that. So for that reason, lexical dimension, so analyzing words and natural language, is a separate dimension even in ontology modeling. And of course, it applies also to similarity of labels and descriptions. In the case of phylogenetical ontology, it is more useful if we look at Latin labels than if we look at English labels. For example, here, silver-tip shark and lesser electric ray, there is zero similarity because there are zero words that share any meaning between those two labels. The membership dimension, I included that because I consider it to be interesting, at least philosophically. It goes in a different direction than the rest of dimensions of similarity from this presentation. It is the similarity of two classes as exemplified by the instances that they have in common. So it kind of goes in an opposite direction than the taxonomical dimension for individuals. So if you think about it, if we have two individuals and they are both Americans, so they belong to the class of Americans, that is evidence of the similarity of those two individuals. In the membership dimension, if we consider, for example, two countries like United States of America and India, I'm sure there are many commonalities between those. We could find many similarities. One that I want to talk about is people that hold both passports, meaning that are both Americans and Indians. And those multinationals are evidence of the membership dimension of similarity, meaning out of everyone that is an American and everyone that is Indian, there is an overlapping part in the middle. And that tells us just one dimension of similarity between USA and India. So knowing that we have multiple dimensions of similarity, which entities do you think are more similar to a silver-tip shark? Would that be the dolphin or the electric ray? Now, intuitively, we would think, well, of course, dolphin and shark are more similar because they both kind of look like a fish, and the lesser electric ray looks like a pancake, and not even a tasty pancake. It's looks ugly. It lies on the bottom of an ocean covered in sand and salty water. Nothing tasty about that. But knowing that this presentation is about similarity and dimensions of similarity, we might be surprised to find that we were right from a certain point of view. Notice that the physical similarity between a silver-tip shark and a short-beaked common dolphin, even based on the short excerpt of phylogenetical ontology that I showed you, is quite big. So we were right. And those creatures are similar. They have similar silver gray coloration. Their features, physical features are similar. They both have small black eyes that look similar. They have dorsal fin. They have the same fins on the side. The fin in the rear is a bit different. It has a different alignment. But in general, those creatures kind of look similar. However, if we look at the result from the taxonomical dimension, it turns out that a silver-tip shark is evolutionarily, if we look at the genetics, more similar to the lesser electric ray, much more similar than it is similar to a dolphin. And that was a result surprising to me because I'm not a geneticist. But notice that this kind of result would be much more useful to a geneticist, which might look at the physical similarity and notice it, and it might drive them to actually investigate further and to dig deeper because they want to discover knowledge. They want to discover similarities that have something to do with their area of knowledge, or to put it differently, they want to have different questions of similarity answered than someone that cares about the physical dimension. So, for example, a diver that sees something resembling a shark, a silhouette underwater, they would probably run. They don't care about the genetic ancestry of that animal. They just don't want to become lunch at this point. At least most divers would do it. I actually have diver's certification, so I don't know if I would do it. Given my knowledge about the dimensions of similarity, I might think, well, I don't know if it's actually a shark. Let's consider its genetic ancestry. That's probably how I die. Anyway, so the reason why we ask the question of similarity is crucial, and it allows us to exploit the dimensions of similarity to the fullest. Now, why would we want to calculate similarity between different kinds of animals. We have on the slide here on the right side, the Ganges shark and Ganges river dolphin. Now notice that they have some lexical similarity, both in English and in Latin. Those are sweetwater animals. We don't see that on the slide. They live in eastern side of India, so their habitat is focused on the eastern side, whereas the silver-tip shark and short-beak common dolphin are more on the southern and western side of the saltwater shores of India. So there are many similarities, of course. Both dolphins have more in common genetically than a dolphin and a shark, as we know from the previous slide. But which result is more important to us depends on what question of similarity do we want to answer. And in this case, if you look at this slide and ask which are more similar, the answer is I don't know, because I don't know. Why do you want to know? And that is where the dimensions come in. Once we figure out why we want to know something, we pick the dimension that is most useful to us. So in summary, we have knowledge management systems, which are systems used in enterprise and social networks that organize information and let us perform reasoning. So producing new information from old information. We use knowledge networks and ontologies, usually based in some kind of formal logic, to drive that inference and to provide a schema for the data. The problem of similarity is applied in many different areas because many different problems may be reduced to the problem of calculating similarity. We have applications in search and advertising, in data processing, in science and medicine as well, in discovery of new knowledge. And we have hundreds of classic measures. And in contrast with that, we have the multidimensional approach, where we propose that entities aren't just similar or different. They can be both at the same time, depending on how we look at it. Thank you for your attention.
Thank you, sir. Thank you for this wonderful presentation given by you.
Thank you.
I request all the participants, like if you have any questions, you can put in chat box. Okay, so on the behalf of 2023 ICACIS Organizing Committee, I extend my heartfelt thanks to Professor Pavel for giving us a wonderful insight on similarity in knowledge management systems. And I extend my heartfelt thanks to all the authors and participants for their patient listening. And I'm sure Sir will always be there to help us resolve our queries in the area related to KDD, entity, syntax or semantics analysis, and finding out the research motivations in the area of similarity and knowledge management systems. So once again, sir, I extend a very, very heartfelt thanks to you for delivering this wonderful keynote session of the day. Thank you.
Thank you, Sofia. And thank you, everyone, for listening to me ramble for almost an hour about similarity and knowledge management systems. And I wish you and myself a pleasant rest of the conference. Thank you.
Thank you, sir. So with this, moving ahead for the fourth keynote session of the day. So we have with us Professor Danilo Pelusi. Professor Danilo Pelusi is Associate Professor of Computer Science at Department of Communication Sciences. He has achieved the qualification as full professor in information processing systems. His research is on coding theory and artificial intelligence. Moreover, he is also interested in signal processing, pattern recognition, fuzzy logic, neural networks, and genetic algorithms. He is assistant professor in computer science from 2009 to 2012 at the University of Teramo. He has developed research activity on control systems, optimization, and database design as Astronomic Observatory Colonia V. Cerulli of Teramo. He has been editor of many books in Springer and elsewhere. He is also associate editor of IEEE Transactions on Neural Networks and Learning Systems, IEEE Transactions on Intelligent Transport Systems, IEEE Transactions on Emerging Topics in Computational Intelligence, IEEE Access, Array of Elsewhere, International Journal of Machine Learning, Cybernetics, and he's also a member of Machine Learning Intelligence Research Labs. He is honorary professor of Ramco Institute of Technology, and he is heading many positions of IEEE conferences as the editorial board. So without any further delay, I now request Professor Danilo to kindly start a keynote on the topic Intelligent Systems for Engineering Problems.
Thanks a lot. Good morning to all, or good afternoon. Here in Italy is morning now. And I share my presentation. Can you see my screen?
Yes, Professor.
Okay, thanks. Well, my presentation will illustrate question of optimization problems and some techniques to solve this kind of problems with the application of soft counting. And in particular, we take into account the fuzzy inference systems and some nature-inspired algorithms named gravitational search algorithm. And in particular, in this presentation, we illustrate an improved version of this kind of algorithm to solve some optimization problems. This slide shows the definition of an optimization problem. In particular, x is a variable which lie in an interval defined by lower bound and upper bound. And the goal of this optimization problem is to find the optimal solution of a specific objective function or more objective functions. In particular, the aim is to find a minimum or maximum of one or more functions under a specific constraint function. In particular, f of x is the objective function, and x1, x2, xn are the solution that lies in a specific search interval. Well, there are problems with some computational problems. In particular, some problems can be solved by exact mathematical procedures, but in this case, we have computational problems because the output of the algorithms is given in a not reasonable time, And this is why there is a huge complexity to solve this kind of problem. In other terms, exhaustive methods are time-consuming, and the problem is which algorithms we have to choose to solve this kind of problems, where there are a huge complexity. It exists a theorem named no free lunch theorem, which states that any two optimization algorithms are equivalent when their performance is averaged across all possible problems. In other terms, there is no algorithm able to solve all optimization problems. We not consider a specific algorithm to solve all the optimization problems. So, in order to solve this kind of problems where the complexity is huge, we have to consider low complexity algorithms. In other terms, we have to consider algorithms which contain some steps with ambiguity. For example, in the traveling salesman problem, it's important to start. But the starting point depends on initialization, in particular, a random initialization. We have to consider this kind of algorithms where there are steps which contain ambiguity. So we can consider non-deterministic algorithms, the algorithms which contain this kind of steps. And in this kind of algorithms, non-deterministic algorithms, we have the following feature, that is, for the same input, these algorithms can exhibit different behaviors on different runs. In other terms, unlike a deterministic algorithm, where with the same inputs we obtain the same outputs, in this case, with non-deterministic algorithms, we have with the same inputs different outputs. This is another approach which we consider, and because we have different outputs with the same inputs, we consider mean and standard deviation of the results. So, non-deterministic polynomial problems are problems solved in a polynomial time by a non-deterministic algorithm. In other terms, exhaustive methods give us results in a not reasonable time, whereas with the application of non-deterministic polynomial problems, we consider the solution of our problem in a polynomial time. Where, well, to solve this kind of a problem where the complexity is huge, we consider soft computing techniques. In fact, to overcome the issue of problems that may take a long time using current hardware, we can apply soft computing techniques. Soft computing is the use of approximate calculation to provide imprecise but usable solution to complex computational problems. Generally, soft computing is referred as computational intelligence. What is the computational intelligence? Computational intelligence is the theory, design, application, and development of biologically and linguistically motivated computational paradigms. In other terms, this kind of computational is very useful where we have problem with high complexity, and we can consider different computational intelligence techniques, and the well-known computational complexity techniques are neural networks, fuzzy systems, and evolutionary computation. Neural networks, which are systems based on systems which have the capability to learn from data. Fuzzy systems, which are systems where we have to provide the knowledge of the phenomenon in study, and the evolutionary computation, which contain several nature-inspired algorithms. In other terms, in evolutionary computation, there are many nature-inspired computing paradigms. And in the last years, there are several different approaches about nature-inspired algorithms. Among these kind of algorithms, the swarm search-based algorithms work with a population-based technique. In other terms, we have a population that evolved during the time, and at each iteration, the current solutions are produced according to historical information obtained by previous generations. The main idea of this approach is to consider the information which came from previous generation, and consider them for the current iteration or generation. So, in other terms, it's very important to exploit the computation of previous iteration to improve the search performances. Among swarm algorithms, we have an algorithm then named gravitational search algorithm. The gravitational search algorithm is a swarm intelligent algorithm which is based on the Newton's law of universal gravitation and the motion of individuals in nature. In other terms, this approach takes into account the Newton's law of gravitational, and there is a model this implement this law, this physics law. The feature of gravitational search algorithm are the gravitational interaction. In other terms, this slide shows the interaction force between two mass at a distance r, and g is the gravitational constant. Whereas the second Newton law states that the acceleration is equal to this interaction force on the mass. Well, this is the main formulas of GSA, but the model presents these formulas where F(ej) is the interaction between two mass Ej, Mj, and it's very important to consider that the solution of our problem is the position of masses. it's very important to consider the position of masses and their acceleration. The aim, the scope is to optimize a specific function. In other terms, it's important to find the minimum of function or maximum of function over the search space defined by x1, x2, xd, where d is the dimension of search space. Well, into the model of gravitational search algorithms, it's very important to consider this formula, which define the gravitational constant. We can note that there is a specific parameter, important parameter, which is alpha. We can note that alpha have an important role because small changes of alpha provide high change in g of t. Specific, G0 is the initial value of gravitational constant, T is the total number of iterations, and alpha is the important parameter. And the idea is to turn this parameter, adjust this parameter, to obtain an improvement about the search performance of our algorithm. Well, the idea is to design a fuzzy inference system which have the capability to turn our parameter alpha, and this is the scheme, a scheme of a general fuzzy inference system where there is the fuzzification interface where the crisp input is changed in the fuzzy out input. There is the fuzzy rule base and the rule of our system. And then there is the fuzzy output, which is converts to a crisp output by the defuzzification phase. This is the main scheme of a fuzzy inference system, and we want to design a specific fuzzy inference system to adjust the parameter alpha and for improving our search performance. Well, the idea is to regulate the parameter alpha, and in order to design a specific fuzzy inference system, we have to choose inputs and outputs, in particular fuzzy inputs and fuzzy output. The fuzzy output is our parameter, our alpha parameter, whereas the fuzzy inputs in our case is the number of iterations referred with n, and a population progress pt, which is defined by this formula. And we can note that an improvement, there is an improvement when the population progress is low. Population progress, which is defined by mean or the fitness function of the entire population at I minus 1 iteration minus the mean of fitness function of entire population on entire population at current iteration. Well, once chosen the fuzzy inputs and the fuzzy output, it's very important to choose the membership functions of our systems. The membership functions are the same for the two inputs, population number and population progress. And because it's very important when we design fuzzy system to choose suitable membership functions. And in particular, we consider, in this case, triangular trapezoidal membership function. And for the output, for the alpha, we consider 9 membership function, triangular membership function, because it's very important to have a more precise, more timed value of alpha. Well, during the optimization phase, in general, we can consider 2 phases. The first phase is named exploration, and the second phase is named exploitation. It's very difficult to share these 2 different phases. And there are several studies on this one, but our fuzzy rules are based on these 2 different phases. Exploration stands for global optimization. In other terms, during the exploration, the algorithms search on the whole search space to find a promising solution and avoid the trapping. It's very important to avoid local minimum or local maximum during this specific phase. Whereas exploitation stands for local optimization, local search, because exploitation exploits the area which came from exploration, and in this area, during the exploitation, the algorithms try to find a promising solution, and so generally the exploration is the first phase of our search process, and the exploitation is the second one of these process. Well, according to exploitation and exploration, we consider the definition of our fuzzy rules, and in particular, when we are in the early phase, that is when the number of iterations is low, the agents must have a big acceleration. To obtain a big acceleration, because we have to escape from trapping, it's very important to have a low value of alpha. In fact, alpha, if the value of alpha is low, then the value of g of t is high. So the value of interaction force is high, and so the value of acceleration is high. In this way, our agent have high acceleration. Another point is when there is an early lack of improvement. That is when the population progress is high and the number of iteration is low. This is a sign of premature convergence, so alpha is very, very low. In this way, this is the possibility to escape from local optima. Another point, for example, is when we are to the end of iterations, to the end of the entire phase of the optimization. If there is an improvement in the optimal research, that is, the population progress is low, then has alpha, the parameter alpha, has to be very, very high, because if alpha is very, very high, then G of T is low, so F, the interaction force F is low, so the acceleration of our agents is low. Well, this slide shows the fuzzy rules in this table, and we have the fuzzy rules surface of our approach. We have these rules, fuzzy rules, and we have this system ready for applying to a different kind of benchmark functions, or to apply to specific optimization engineering optimization problems. For example, we consider our approach with fuzzy logic to unimodal functions. Unimodal functions are functions useful to assess the exploitation phase of our algorithm, because unimodal functions have just one local optima, and with this kind of functions, we can assess the goodness of exploitation phase. Moreover, our algorithm is applied on multimodal functions as well. Multimodal functions are functions very useful to assess exploration phase, because multimodal functions have multiple, more than one local optima. And this way, it's very useful to assess the exploration phase of our algorithm. In both cases, there is a comparison between GSA, gravitational search algorithms, and our gravitational search algorithm with the fuzzy inference system applied. And we can note that there are improvements about the find of the minimum value of benchmark function. And in both cases, we find the minimum value first, then comparison algorithm as well. Well, but if we consider this rule of our system, and we consider in particular the number of iteration n and just the parameter alpha, we note that there is a trend, an increasing trend of alpha with n. In other terms, we can note that alpha increases with the value of n of iterations. So the idea is to define a specific function, an increasing function of alpha over the number of iterations. And in fact, the mathematical approach is characterized by the passage, the point from rule table to a value of alpha defined by a mathematical formula. In other terms, we consider that alpha increases with the iteration number, and another approach which take into account the fuzzy rule table. The other approach is to consider a function of t, where t is the number of iteration in this case, and the big T is the max number of iteration. Taking into account the fuzzy rule table and this aspect, we define alpha by choosing the hyperbolic function, because with this kind of hyperbolic function, we have no dependence from chain parameters, and alpha only depends on quantities computed inside GSA. In other terms, we calculate this parameter without other computation. In other terms, the computational complexity is the same. Well, we apply our gravitational search algorithm with the hyperbolic function defined by this formula. With other swarm algorithms, such as mode flame optimization algorithm, for example, BAT algorithm optimization, and so on. We can note that our algorithm, the hyperbolic gravitational search algorithm, is the best algorithm compared with other important and well-known swarm algorithms. But our approach, our mathematical approach, is useful to solve engineering problems as well. For example, we have applied our hyperbolic algorithm to the 3-bar truss design problem, where the aim is to minimize the function f of x subject to specific constraints. In this case, the number of constraints is 3. If we apply our hyperbolic GSA, we can, this problem in the 3-bar truss problem is very important to find the optimum cost. We can note that our algorithm achieves a very, very good result. And conclusion, in order to solve the problem of complexity, it's very important to consider soft computing techniques, in particular the optimization by swarm algorithms. Enhanced by fuzzy systems, and taking into account the design of these fuzzy systems, in particular of fuzzy rules, consider an hyperbolic approach to regulate important parameters. In this case, in the case of GSA, we consider the alpha parameters. These are the reference of the do presented approach, and thanks a lot for your attention.
Thank you, Professor, for this wonderful presentation. I request participants, if you have any questions, we can have few questions. Any questions from the participants? Okay, so on the behalf of ICACIS Organizing Committee, I extend my heartfelt thanks to Professor Danilo Pelusi, Systems Research Institute, Polish Academy of Sciences, for his wonderful session on intelligent systems for engineering problem. I extend my hearty thanks to all the authors and participants for their patient listening. And like whenever we have any research questions or any problems related to the topic as mentioned, we can always be in touch with the professor and he'll be always ready to help us, right, Professor?
Thanks a lot.
Thank you so much, sir. It was a wonderful insight towards the topic on intelligent systems for engineering problems. And I'm sure that you have shown a very, very nice roadmap to all the young researchers for their future research work. So this will help me personally a lot, being from a computer science background. So once again, thank you, Professor, for this wonderful, wonderful keynote session. Thank you.
Thanks a lot and good work to all. Thanks.
So this was the keynote session 4. I request all the participants to come back at 2 p.m. for the last technical session of the day. So now we can take a break of around 20-25 minutes where we can quickly go and have lunch and come back at 2 p.m. Thank you all.
Hello, sir. I am audible. Hello.
Yes, audible.
Okay. Thank you, sir.
Hello, everyone. Our technical session chair, Dr. Pawan Kumar Singh, actually joining shortly, so we will start once he joins. So please, everyone waits only for 2-3 minutes. Once he joins, we will start our technical session 4. Thank you all. Hello, everyone. Welcome you all for our today's fourth technical session. So I, with my coordinator, welcome you all for the International Conference on Advanced Computing and International Intelligent Systems. Sorry, I take actually this opportunity to welcome to our session chair, Dr. Subroto Sahana and Dr. Pawan Kumar Singh, and all the authors for this session, TS4. Actually, this ICACIS will provide an opportunity to all the engineers, academicians, and researchers to meet in a forum to discuss various issues and its future directions of various emerging technologies of allied areas of industry applications. The conference aimed to put together the experts from the relevant areas to disseminate their knowledge and experience for the relevant future research scope. The conference has publication sponsored by CCIS Springer Nature, and it is give me an immense pleasure to introduce our today's session chair, Dr. Pawan Singh. He is Associate Professor, Department of Computer Science, School of Mathematics, Statistics and Computational Science, Central University of Rajasthan. He has completed his PhD from the Department of Computer Science, Indira Gandhi National Tribal University, MP. He has completed his MCA from the Harcourt Butler Technological Institute, Kanpur, and BSc from the CCS University, Meerut. His area of specializations are vehicular ad hoc network, FINET, sensor network, Internet of Things, and the deep learning. In a case of the working experience, he is an associate professor in a Department of Computer Science, Central University of Rajasthan, Ajmer. And prior to this, he is an assistant professor, Department of Computer Science, Indira Gandhi National Tribal University, MP. He is also served as an assistant professor, Department of Computer Science, Chaudhry Charan Singh University, Meerut. He has contributed in many research publication, international, which is in a national and international patent book chapters, in conference, workshops, and seminars, FDPs too. He is a member of professional bodies, CSI and UACEE. So welcome, sir, in our today's conference. Our second keynote session chair is Dr. Subroto Sahana. He is working as an associate professor in a department of CSE at Sharda University, Greater Noida. He received a PhD in computer science from the JNU New Delhi and MTech in computer science and engineering from BIT Mishra in 2010. And BTech in computer science and engineering from CEMK West Bengal University of Technology in 2007. He joined Sharda University as an assistant professor in 2019 and promoted as associate professor in January 2021. Prior to this, he was associated with Galgotia University as assistant professor, VIT University, Vellore, and then Jamshedpur in RVSECT University, Jamshedpur. He has rich experience in publication in many international journals and conferences. Moreover, Dr. Sahana has also delivered the expert talk, guest lecture in international conferences and serving as a reviewer of journals of IEEE, Springer, Global, etc. His research area is underwater wireless sensor network, pattern matching, bioinformatics, IoT, security, and cryptography, etc. So welcome you both of sir in our today's session. With this wonderful introduction, now I would like to request our respected session chair to give us permission to start the video presentation of the papers.
Please go ahead. Thank you so much for introducing us. Please go ahead.
Thank you, madam. Please proceed.
Excuse me, sir. Pawan sir, am I audible?
Yeah,
Yes, madam, you are audible.
yeah, you are audible, ma'am. Please go ahead.
Okay, sir. Now, one more announcement is for the presenters. We are going to play the pre-recorded presentation, and I request to the respective authors to unmute yourself once the presentation is played to answer the session chair and audience questions. And attendees can post their question in the chat box. So with this, we will start our technical session 4 with the first paper ID is 175. Presenter is Dr. Prashant Wirtz, and the paper title is Development and Evaluation of Artificial Intelligence-Based System for Pancreatic Cancer Detection and Diagnosis.
Good afternoon, ladies and gentlemen. My name is Dr. Prashant Wirtz. Today I'm here to present a paper on the topic. Paper ID is 175. The topic is development and evaluation of an AI-based system for the pancreatic cancer detection and its diagnosis. So this is an overview of our presentation that we will be discussing with, first of all, with the abstract. Then we are going to discuss about the introduction. Then we are going to discuss about the related work. Then we are going to talk about the proposed methodology. Then we are going to talk about the experimental results. Then we'll be briefing about our conclusion, and then we will be taking on the references. So abstract, if you'll see, when we talk about the pancreatic cancer, so basically due to the late stage diagnosis, cancer detection, or you can say pancreatic cancer becomes extremely fatal with the, you can say, with a poor survival rate. So improving patient outcomes requires the creation of precise and effective diagnostic technologies. So basically the goal of this project is to create and access an AI-based pancreatic detection and diagnostic system in order to deliver the precise and fast resolution, which the system will be analyzing using the clinical data and medical imaging data using the machine learning algorithms. So the late-stage diagnosis, or you can say the poor prognosis of the pancreatic cancer, basically make it a particularly deadly condition where the condition of precise and effective diagnostic tool is essential for enhancing the patient's outcome. So this article basically describes the creation and assessment of an AI-based pancreatic detection and diagnostic system. In order to provide a precise and rapid system assessments, the system basically analyzes the clinical data and medical imaging data using the machine learning algorithm. So basically this approach entails the gathering the pertinent data and performing its feature abstraction. So when we talk about the introduction, so malignant computer, they are tumors, basically they are called as pancreatic cancers. They develop in the cells of the pancreas, where a glandular, which is a glandular organism, you can say organ beneath the stomach. So its dismissal percentage of survival is a result of strong aggressiveness and frequent diagnosis of the disease at advanced stages. Various symptoms and health issues might result from the pancreatic cancer, as it can prevent the pancreas from operating normally. So basically age, smoking, being overweight, having chronic pancreatitis, having a family history of the disease, these are the basically various risk factors of the diseases. So study of patient's medical history, physical examination, imaging tests like CT scan, MRI, and endoscopic ultrasound and lab testing. These are the frequently used techniques to diagnose the pancreatic cancer. So basically, the stages of the diseases, the patient's general health and performance preferences, they also affect the patient's capability to receive the pancreatic cancer treatment. So basically, number of reasons are there where it is crucial to identify you can say it is crucial to identify and treat the cancer as soon as possible. So basically, better treatment alternatives, better prognosis and survival rates, improved quality of life, targeted and personalized therapy, and cost effectiveness. So these are some factors. So why the role of artificial intelligence is there? Now we will talk about the greater diagnostic accuracy that has been provided by the AI-based algorithms. It also gives the risk assessment and prediction modeling. It will also help you to basically precise the medicine and treatment planning specifically with the targeted areas. It also helps you to take the clinical decision support system and the workflow optimization and efficiency. So these are some of the related work that we have carried out, into which the various researchers, they have implemented various sort of algorithms in you can say identifying the pancreatic cancer diagnosis. So how they can help with the risk assessment, treatment planning, and accurate diagnosis. They have basically launched their studies onto that. They have also provided various methodologies with the high sensitivity and specificity that has been attained by the various CNN model. So these are the work that has been done by the various organizations, authors in the specific research areas. So this is our proposed methodology into which we have proposed AI-based pancreatic cancer detection and diagnosis system, into which we will be inputting the data as the clinical images. And then our system will be taking a pre-processing and based on feature extraction and machine learning, we will be identifying the crucial areas that are meant for the diagnosis, and then we will be predicting the output. So in this case, these are our experimental results that we have carried out by the pre-processing and feature extraction with the development of machine learning models, where we are loading the data into the algorithm framework. Then pre-processing, feature extraction, splitting data, building model, training the models, then making prediction, evaluating the model. Then these are the results that we have carried out with the clinical analysis. These are some of the images, as you can see over here. So these are our performance matrices that we have obtained after concluding our framework with the AI algorithms, and our performance has been specified into this. How we have been differentiated with the AI-based system and human experts has also been explored in this. So in conclusion, we can say that the creation of an AI-based system for the detection of for the diagnosis of the pancreatic cancer has a greater promise for enhancing a patient outcomes with the early detection rates. So these technologies have the potential not only to improve pancreatic cancer detection precision and efficiency by utilizing the machine algorithm, but they also provide you cutting edge image processing techniques. So in this, we have talked about that how the AI can be helpful to provide the better patient care and diagnostics into the healthcare industry. Also using image modalities, pre-processing methods, feature extraction, and machine learning algorithm, we have examined the related research and methodology in the field of pancreatic cancer diagnosis. For several phases of the pipeline, including pre-processing, feature extraction, and model creation, we have supplied the pseudocode and sample Python code snippets for the implementation of this algorithm. So with the conclusion of this, we are going to end our presentation. And now these are the references that we have referred. So you can have a look onto this. So with this, I'm going to conclude my presentation. Thank you so much. Thank you, ma'am. Thanks for the presentation. Any questions from the?
Okay, doctor, it is a nice presentation. Am I audible to you?
Yes, sir. Yes, sir.
I have some queries.
Yes, sir. Please.
First of all, just tell me what are your future scope for your further study? What you are going to do in future?
Future scope, basically, we are looking for classifying the and future direction is to automate the system for the large scale databases.
What machine learning models you have used in your
CNN CNN models and naive bias classifiers we have used, sir.
Okay, you're using CNN.
Yes, sir.
Okay, how many layers you have used in CNN?
So right now, Pardon for that.
Okay, and have you tried to implement on which platform you have implemented?
We have implemented this on Python.
On Python, which library you have used for the CNN?
So the libraries we have used, I don't pardon right now.
Okay, and I was just checking your references. The references are not up to the mark.
Okay.
You haven't used the references from.
We will keep in mind for the future research, sir.
Okay, and just try to implement some CNN or deep learning, even
sure, sir, sure.
Test deep learning models. There are a lot of deep learning models are there, and you can
sure,
utilize
sir,
that.
Sure, sir, sure. We will keep this in mind.
Okay, thank you so much. It was a nice presentation.
Thank you, sir. Thank you. Any other more questions?
You have calculated the precision value.
Yes, sir.
What is the role of precision value?
So role of precision value will be providing you the accuracy of your data set, that how the data set has been trained. They are working actually towards the prediction of your models.
No, how it is related with accuracy. That I'm asking.
So related with your accuracy of data, because training of data sets are required for, you can say, making the predictions and analysis for the image classifications. So accuracy is required over there, sir.
What is the range of precision value?
So, pardon for that right now.
And what is the feature extraction model you have used?
So, pardon for that right now.
Okay.
Thank you. Thank you, ma'am. Thanks for the opportunity.
Thank you, sir. Now we will move for the next paper presentation. The paper ID is 428. The paper title is Method Comparison for Predicting Student Retention at a Private School in Indonesia.
Hello, my name is Abiola Pangabean from Pelita Harapan University in Jakarta, Indonesia, and today I will be presenting my paper that I wrote with corresponding author, Mr. Yugo Puspito, titled Method Comparison for Predicting Student Retention at the Private School in Indonesia. When customers feel satisfied with a product or service, they will purchase it again and recommend it through word of mouth, which means they will retain. If they are not satisfied, they will complain about it, or, worst case scenario, they will not buy it anymore in the future and will not recommend it to others. In other words, eventually, the customers will churn. Of course, every company does not wish to have churning customers, but rather the loyal ones who will repurchase their products. Companies are doing their best to retain their customers because it is more beneficial than acquiring the new ones. In fact, if a company can retain just 5% of its customer, its profit will increase, and it can reduce marketing and operational costs while at the same time increasing its sales. Therefore, a small improvement in customer retention prediction can really help a company save a lot of money. Both customer retention and churn are important for most companies from various industries, including the field of education. If a school provides excellent service, it can cause satisfaction for the parents and make them want to enroll their children to that school. This also applies to parents who want to re-enroll their children to the same school for the next academic year, which can be called as customer retention in education. This research calls it student retention. Student retention prediction is necessary for schools because it can identify students who are most likely to churn and help school management to evaluate and improve its service, learning system, facility, and even customer relationship management strategy. This research raises a case study of a private school in Indonesia that has a target of student re-enrollment or retention. Usually at the beginning of an academic year, the school's management makes a list of student retention. In this list, the management will mark the ones who will most likely continue their education in the next academic year and who will quit. It is challenging for the school to come up with the right customer relationship management strategy to overcome student retention issues. The research is conducted to use machine learning models to help and predict student retention. In the future, this school can get a more precise result of prediction through machine learning, anticipate the parents and students who are showing signs of not continuing their education in the next academic year, and make a better customer relationship management strategy. According to the findings from past studies of student retention prediction, random forest, logistic regression, support vector machine, and neural network are popular amongst other machine learning models. Therefore, this research uses those four models too. Random forest is a tree-based learning algorithm which is known for its low tendency to overtraining and its high accuracy. With its ability to handle large and complex datasets, random forest excels in capturing intricate relationships between various factors affecting student retention. Its strength lies in its robustness against overfitting and noise, resulting in more accurate predictions and reduced false positives. Logistic regression is a classifier that estimates the probability of a binary output target. It is one of the most widely used statistical techniques that holds several benefits in student retention and churn prediction. It identifies the relations between the output target or dependent variable with a set of independent variables and compute the occurrence of an event happening based on predictors and weights. Support vector machine is a supervised learning algorithm that analyzes data for regression and classification. It works by finding the optimal hyperplane that separates the data into two classes with maximum margin. To achieve this, support vector machine transforms the input data into a higher dimensional feature space using a kernel function, and this transformation helps in finding a decision boundary that can effectively separate the students who will retain and the students who will churn. Neural network is an algorithm that transforms inputs into desired outputs using highly interconnected networks of relatively simple processing elements neurons. The power of neural network lies in its ability to automatically learn complex patterns and relationships in data, making it a key component in deep learning models that tackle tasks requiring sophisticated modeling capabilities. This research is using a private dataset from a private school in Jakarta, Indonesia, to predict student retention for the academic year of 2023 and 2024 based on the data from the academic year of 2021 and 2022. The collected data is from 2 years before the actual enrollment in question, because the enrollment itself will start in the second term of the academic year of 2022 and 2023. Therefore, it is necessary to use the data from the 2 years prior so that the school management can come up with the right CRM strategy during the first term of 2022 and 2023 academic year to maintain student retention. The dataset collected are demographic data, enrollment data, parents' satisfaction survey data, and observation of parents' behavior. Data preprocessing or data preparation is a phase that is done before the actual prediction experiment. Several steps are taken to prepare the data before continuing to model development and experiments. Data cleaning is applied to transform raw dataset into a format that was more compatible for the modeling process later. A tool called Orange 3 is used to handle the preprocessing up until the experiment. All data from 4 separate datasets are joined. There are 483 rows obtained, which means there are 483 students who should re-enroll or retain in the academic year of 2023 and 2024. Initially, there are 32 features captured, including the output variable, which is the student retained or not. There are more features added through features extraction, so the total of features is 37, and those are area, sibling active, sibling re-enroll, satisfaction in learning process, satisfaction in teacher's interaction with student, observation of parents' behavior, and the output target, student re-enroll. The commonly used performance matrix to evaluate student retention and churn predictions are confusion matrix, which is a matrix used to compare prediction results with the actual class depending on a positive and negative value. AUC is the area under the receiver operating characteristics or ROC curve that ranges from 0 to 1, A model with AUC value closer to 1 is considered a better model. F measure of F1 score is the harmonic mean of precision and recall. F measure is used as a single metric for evaluating classifier performance. Accuracy is a proportion of the total number of predictions that were correct. Accuracy is used to measure the total proportion of the students whose final status, retain or churn, is correctly predicted by the model. Precision is the proportion of the predicted positive cases that were correct. Precision is used to determine the proportion of students that were actually retainers among all the other techniques that predicted as retainers. Recall is the proportion of positive cases that were correctly identified. These metrics assess the effectiveness of machine learning models in various tasks, including classification, regression, and clustering. The selection of appropriate metrics depends on the specific task and desired evaluation criteria. It is common to consider multiple metrics together to gain a comprehensive understanding of the model's performance and to select the best model for a given task. And for this experiment, the metrics that are used are accuracy and AUC. The experiment uses random forest, logistic regression, support vector machine, and neural network. The clean dataset is trained using these models, and then the trained models are used on the testing data for evaluation. The parameters used in the orange 3 for those 4 models can be seen in this presentation. In this experiment, each method will produce confusion matrix for training and testing data. The complete results are tabulated in Table 2 and 3 as training and testing respectively. The maximum number of the true and minimum number of false are achieved by the random forest model, followed by the support vector machine model. And the results of the AUC, accuracy, F1 score, precision, and recall are shown in Figure 3 and Figure 4. Random forest model gives the best result, followed by the support vector machine model. In conclusion, the analysis results reveal that for the training model, random forest is the best machine learning model to predict student retention. But when applied to the testing data, the best machine learning model to predict student retention is random forest, followed by support vector machine. Nevertheless, all machine learning models in this research are showing good results. That is all about the paper I wrote, and thank you so much for listening.
Okay, I have just one question.
Yes, sir.
To the researcher. First of all, I was not able to see any references in your PPT. And I have one more question, that what are the differences between a random forest and logistic regression model?
I'm sorry, sir. Can you please repeat the question? My signal is not so good. Sorry.
Are you able to listen me now? Are you able to listen me?
Can you please repeat it, sir? Sorry.
Am I audible to you? Am I audible?
Yes, yes. Okay, sir.
Okay. What are the differences between random forest and logistic regression?
Okay. So for the random forest, as long as I know, it is a tree-based algorithm. So it is used a lot of trees, and then they put it together to then come up with the best prediction. Sir. And then for logistic regression, it is a classifier that the output target will be binary. In my case, will be retain or not. The students will retain or not based on the variables input.
Okay, thank you.
Thank you, sir.
Any question from anyone's side?
Hello.
Okay, thank you so much. Yeah. Yes, sir.
Yes, I'm audible.
Yes, sir.
Not to you, not to the author only.
Yes, sir. Yes, yes.
Author? Yeah, author, I'm audible to you.
Yes, yes, sir. I can hear you. Yes.
What is the outcome of your paper?
Okay, so the outcome of my paper is I'm trying to predict the student retention. And the outcome is the random forest was able to predict most of the retaining students, followed by the support vector machine. So it can be said that the random forest is the most optimal in predicting correctly the students who actually retain or re-enroll in the next academic year, sir.
But random forest, it is performing better or best, that already proven. So I no need to prove it. No, I can use that data.
I'm sorry,
Previous
sir?
research, if you go through the literature survey, so random forest, you will get the best result. So why I have to prove it again?
Okay, so from the reviews that from the papers that I previously studied, there are not many studies that come up with this topic, especially in Indonesia and especially in private schools, sir. Mostly they come up with the object of university, so that's why I decided to use the object of private school and the topic of student retention, sir.
And what is the interpretation of your figure 3 and figure 4?
I'm sorry, sir?
You have shown figure 3 and figure 4. One
Yes.
graph analysis is there. Testing and
Uh,
training data.
Yes, so when I run the 4 models, for the training data, it is random forest with the most optimal in AUC and accuracy. Accuracy and AUC are the matrix that I use. But on the testing data, random forest is also the best optimal model, followed by the followed by the support vector machine, sir.
Okay, thank you.
Thank you, sir.
Okay. Okay, just do a little bit faster now because we are already behind the time. The coordinator, it is requested to you just move a little bit faster so that we can complete within a time.
Okay, sir. Okay, sir. Sure, sir. In next presentation, we will follow it likewise.
Okay, thank you.
Yeah. Thank you so much, ma'am. Now, next presentation we have the paper ID 748. Paper title is Distribution and Semantics of Terms with the component white in Bulgarian language, a statistical approach. The presenter is Lises Leva. Ma'am, are you present?
Yes, I'm here. Can you hear
please,
me?
Ma'am. Yeah, ma'am. We can hear you. Ma'am, please share your presentation.
Okay. Can you see?
Yes, ma'am.
Okay, I'm starting.
Ma'am, it is a request to you, please skip, after the introduction, please skip some part of the presentation and start with the result, ma'am, actually.
Okay. The title of my
some
talk.
Introduction. Yeah, thank you.
The title of my talk is The Distribution and Semantics of the Term with the Component White. I'm starting with the introduction. The contemporary linguistic research actively uses statistical approach. That is the approach we have used for that study. Generally, the approach was using for processing big language data to extract the knowledge about the word semantics relations. That techniques can be used and is a very reliable tool for extracting the semantics of both lexical of lexics and terminology, but because there is a difference between the semantics of lexics and terminology. The analysis and presentation of terms are classified according to different types of classification. Terms can be of different use, but the main point and the main characteristic of that classification is the hierarchical structure, which is very suitable and very useful to be presented as an ontology. And as we know, the ontology we can extract by using several approaches. First of all, I'm like a little bit to skip through the colors because colors have been studied from different perspectives. Colors have been studied from the point of view of physics, and it is light with a fixed wavelength. Then from the lexical semantics, colors have been studied from the point of view of nomination theory, or the type the colors have been naming. From the psycholinguistic point of view, there are the studies in which there is followed which color, what type of results in the human brain gives, or what type of reaction. And further, we are going to show you how we have used the colors and how we have extract the color terms from the Bulgarian language with statistical approaches. We have used the distributional semantics model, and the distributional semantic model regards the statistical similarity as related to semantic similarity. So if we get the most frequent words, and their relations, we can be very sure that we can find in that way the lexical relations. For that, we have used the sketch engine software. The sketch engine software is a search machine for processing electronic text corpora that allows the use of a combined statistical approach for semantically similar words. The keywords are evaluated on the base of word frequency list and are generated using the statistical search. We have used mainly the three type of scoring. These are the formulas. For them, the following terms are: N is the corpus size, A is the number of occurrences of the keyword in the full corpus, and etc. As a database, we have used the BG 101012 corpus, which is a corpus from the 1010 family corpora, which are corpora crawled from the web. So we have extracted that data, linguistic data, from the web. It is created from the web text materials using the Spiderlink tool, which collects only linguistically valuable text, and the technology includes the downloading, web downloading of text, cleaning text from the linguistically relevant content, tokenization, and removing duplicated text paragraph. The received corpus is lemmatized and tagged according to the part of speech, and finally is annotated. The BG1010 corpus consists of approximately 75 million words, so it is very big enough to have a reliable results. The first results we have received is the all occurrences of the word white, and we have found that the white was occurred in our corpus 134, approximately 34,000 occurrences, but it is a qualitative context. It is not a semantic context. So we have extracted later the collocated words. That idea of collocation is based on the fact that if two words have a common collocation, so they are semantically related. And in the figure here, there is the first top 11 words which we have received as the most frequent to be combined with the word white. And they are lung, world, wine, color, horse, red, etc. However, all these words give a very meaningful combination with white, and they give white world, white wine, white color, white horse, white black, and white red. Then we have also received some other results like more collocations like bread, light, etc. More complicated semantic search with the terms white together with like, with the preposition like. We have received also a very interesting results like snow, milk, and cheese, which are in the green color part, and also and these are the prototype terms. The prototype terms are also the canvas and angel, and also rival terms, which is a purity. The semantic relations and or, which is also very, very important. This is the synonymic and hierarchical relations, give as a result black, red, green, etc. These are 11 color system terms, which means that the Bulgarian language is 11 color system terms. All they are basic color terms. Other terms which we have studied is the transition white-black and transition white-red. We have studied very carefully the transition white-red, which is also interesting that it gives the results like gray, the results like yellow, blue, green, etc., which are more closer to red than to white. Later, we have studied also results related to extraction the thesaurus. The thesaurical relations are more complicated relations than the collocation, and they give much more sophisticated relations, semantic relations between words. And such results contain within the main core part of the cluster. These are also the color terms like white, black, green, and red, but also some other more interesting terms. And finally, we can conclude that the word white as presenting a color is a basic color terms that has light, snow, milk, and cheese as a prototype terms. Additionally, the prototype terms have a semantic feature of purity, which is a basic feature of the color term. Does white symbolize light, pure, beautiful, and healthy things? Some researchers regard white as having a semantics of inclusiveness in light, since light as a prototype of white includes all colors physically. And our result also improved more than this. Consequently, white has very complex semantics that process the attributive of the colors themselves. Also includes brightness and transparency, as well as to symbolize the feeling of warmness and tenderness. The terms with the component white in the contemporary Bulgarian language present attributive collocations and express a semantics that relate to the basic feature of the prototype terms of white, as in the white dress, white uniform, which is the uniform in medical institutions, and which symbolize the healthy institutions, and the white paper, which symbolize the purity or the white bread, which symbolize also the purity or unmixedness. Also, they express the semantics of nothing, as in the combination in the white spot, and which symbolize the lack of some things. Finally, the term with the component white express the semantic of the basic color terms, as in the white wine and in the combination white horse. Thank you for your attention. I have already finished.
Any questions, sir, please?
Yes,
Okay.
I have finished already.
Okay,
Yes,
ma'am.
ma'am.
Okay, I have just one query. What is MI score you have used? What are the matrices for this MI score? What does it mean basically?
My score is a probability.
Okay.
The probability of co-occurrences. These three metrics have give a different results. The best results give MI3 score, but we are checking for all three of them, because sometimes they are giving, especially in the collocation combination, when we have a complex term like white horse or white wine, the MI3 score is the best measurement.
Okay, what are your future scope for this particular research? What are the future direction?
We are planning to study different colors also. This study was devoted to the white color because white was maybe the most complicated, but we plan to study the other colors. And also because the metrics is statistically based, we also expect that it can be useful to be applied for some other languages to study their cultural meaning of the colors within their cultural contemporary culture, because for the past culture it could be applied, I think, more complicated.
Okay, thank you so much. It was a nice presentation. Thank you.
Thank you.
Any other questions from anyone?
Thank you. No question from us.
Okay, thank you, sir. Thank you, ma'am. Ma'am, please do the stop sharing from your end.
Sorry.
You start this next one. Huh?
Yeah, now next the presentation we have paper ID 873. The paper title is Information Technology and FinTech Innovation and its Effect on Indian Financial Services. The presenter is Dr. Deepa Chauhan.
Yes, ma'am. Good afternoon. Good afternoon, everyone.
Good afternoon, ma'am. Will Sleva, ma'am, please stop sharing?
And FinTech innovation and its effect on Indian financial services. These are the topics to be covered during presentation: introduction, literature review, research methodology, FinTech and its effect on Indian financial services, factors motivate for adopting financial technologies, major barriers for adopting financial technologies, challenges, findings and suggestions, references. Let me introduce first FinTech term. FinTech is a new term going to describe financial services, related technology innovation. Governments are currently working to define FinTech, which is a broad term that lacks scope. A wide range of benefits may be gained through FinTech technology, including enhanced performance and cost reductions. As we know, FinTech, yes, this term is using advanced technology, innovative technology, and reducing cost by making a use of such technology. FinTech sector in India is indeed expected to grow rapidly in coming years, with a projected compound annual growth rate of 22%. This makes India one of the fastest growing FinTech markets in the world, and it's already considered to be the third FinTech ecosystem after the US and China. This growth is driven by a combination of factors, including a large and growing population of tech-savvy consumers, a supportive government policy environment, and an entrepreneurial ecosystem. Now we can see segment-wise fintechs here. According to this graph that follows the investment technology sector, it accounts for 28% of 6,386 fintech companies, while the payment sector accounts for 27% and the lending sector accounts for 16%, whereas banking infrastructure accounts for 9%. Objectives: of researchers. Research methodology. The goal of this study is to assess the current level of information technology and fintech's effects on Indian financial services. The study is entirely based on secondary data, and data has been gathered from different websites and research papers, case studies. Now let's discuss fintech and its effect on Indian financial services. There are some effects given. Yes, fintech effects on equity funding services, developments in blockchain technology in India, cross-border payments, syndication of loans, capital markets, developments in payments landscape in India, and other fintechs. If we say equity funding services, while crowdfunding methods are growing increasingly popular, obtaining project cash can be difficult. And these services are targeted towards startups and small enterprises that are just getting started. Just a few examples are Start 51, Wishberries, and T2. And if we talk about the developments in blockchain technology in India, there are a number of domestic firms that have lately shown an interest in blockchain and its supporting protocols, which are presented in the form of enigmatic record. After doing research on whether or not BCT can be implemented in Indian banking and financial sector using a white paper that covers the relevant time period issues, worldwide examples, and possible areas of adoption in India. Next is syndication of loans. The distributed ledgers, we can say monetary implementation information may be used to automate underwriting processes. The KYC rules can also be automated in real time. BCT can offer an international fee reduction option for syndication loans. In the system, execution and agreement sub-processes, capital markets, off-exchange mistakes are reduced or eliminated, back office operations are simplified, and agreement times are decreased with BCT clearing and settlement techniques. If we talk about the BCT banking operations in India, Indian banks have asserted that BCT may be used effectively in their operations, such as for international remittances or for other purposes in the past several years. According to them, it has the potential to become an integral part of their banking operations on a much larger scale. Developments in the payments landscape in India. There has been a lot of innovation in India's financial sector. Thanks to the use of financial technology, coins have given way to a new form of payment in India, reflecting a normal rise in country's economy. IMPS, UPI, these are some traditional, we can say, bill payment methods. Nowadays, we are using MobiKwik, Oxygen, Citrus Pay, and many more. BMAP, there are some UPI, we can say, linked app. Other fintech, diverse fintechs, we can say, are companies that offer services other than traditional banking, such as financial accounting and asset management. Coverage includes search engines and assessment websites, as well as technology, as well as infrastructure. Financial generating businesses have also taken over the insurance market. In this area, distribution is primary focus for the vast majority of businesses. Apps like these are being used by these companies to reach out to their target audience. They are not, we can say, your standard insurance company. Instead, they have a lot of latitude in order to compete in the heavily regulated insurance industry. Startups are trying to join up evaluation sites. Factors motivate for adopting financial technology is of setting up of an account. There are some major barriers for adopting financial technologies. Lack of awareness. People are not much aware about the, we can say, fintech term, and with the, we can say, features and functionality of advanced technology for financial services. Lack of proper knowledge of their usage and functions. Feel traditional financial services provided as more reliable. Now, at the end, to conclude my research, I would like to say financial technology is predicted to displace traditional banking practices. Banks will adopt modern information system, and fintech firm will subject to greater regulation to protect their customers' data. This coming together will mark the beginning of a whole new technological stage in the development of financial sector. There are some recommendations given for managers of financial technologies, companies, new businesses, and venture capital funds. The founders of fintech firms need to have enough training in both the technical and financial aspects of the industry. The payments industry has produced a significant number of prosperous startup companies, and it's anticipated that this trend will also prevail in other areas of financial industry, not only in the, we can say, financial sector. Exceptional steps need to be taken in order for the government and other regulatory agencies to make even more of an effort to encourage the financial technology business. These are some references given. Thank you very much.
Please,
Yes,
any
anyone?
questions? Yes, ma'am.
Yes, waiting for the question.
Okay, what are the research outcome of your title, of your paper?
Sir, research outcome is there are some challenges, in fintech sector. How can we overcome such challenges using, we can say, by doing more research and using some, we can say, models. I haven't used model, but I'll be using in my future research some model to know this sector, because we know fintech, it's an emerging concept, and yes, in future we see there will be digitalization, and presently we are also using some digital, we can say, apps, UPI and all.
Digitalization is already in the market now. We are using
Yes,
UPI
the market,
last 5 or 7 years before, and even the banking sector is totally digitalized.
Yes, sir, but fintech is something different from
What is
this.
the new in fintech, basically?
Fintech, sir, we can say it's
paper is pure. Your paper is pure theoretical.
It's a convergence of financial services.
Your paper
and
is pure
technology,
theoretical.
Yes, sir, theoretical. Yes, sir. Next time I'll do some data, more research on this.
Can this paper is fit in particular technical session? I don't think so. This is I don't think so that this paper may be fit in that particular technical session where you are presenting this paper.
Sir, I have you must next time I'll use some data.
You must present some paper that are related to the business analytics, basically, not
yes,
in that
sir, yes,
particular
sir,
session. You must submit somewhere this paper, basically. This is not belong to that particular area, basically.
So this is related to
the title is
finance
basically from
and
the
technology,
robotics.
that's why.
This is basically from the robotics and AI based, basically.
Okay, sir.
And the references, whatever I'm checking, these are very old reference we have taken. Okay.
Okay, sir.
Okay, thank you, ma'am.
Okay, welcome.
Now next presentation, we have the paper ID is 1828 and paper title is Sanskriti OCR System. Sorry, Sanskrit OOCR system.
Hello everyone, myself Yuvraj Edle. Today I am going to present on Sanskrit OCR system. The authors for the same are Professor Jyoti Madke, Yuvraj Edle, Vaibhav Sahapte, Professor Shripad Bhatlamande. These are the contents of the PPT. So first of all, let me talk about the introduction. So Sanskrit is one of the oldest languages in the world and has rich literary heritage. Many valuable Sanskrit texts are ancient manuscripts that need to be preserved and digitized for easy access and long-term preservation. Converting physical Sanskrit text into digital format allows for easier storage, searchability, and distribution. OCR technology enables the efficient conversion of printed Sanskrit text into editable and searchable digital content. Sanskrit holds a prominent place in Indian cultural heritage, and preserving its vast body of literature is crucial for the continuity and understanding of the cultural and intellectual traditions associated with it. So OCR facilitates wider access to these texts for scholars, students, and enthusiasts worldwide. So that's why we selected these topics. Our aim is to digitize ancient Sanskrit literature, and our aim is to recognize the handwritten character. So, talking about the literature survey, we refer 20 to 25 papers which are included in our research paper. So, these are the four papers that are most relevant to it. First one is OCR for Sanskrit using convolution neural network. As the name suggests, they use convolution neural network, and they use SVM classifier. Next paper is Sanskrit word recognition using private operator and support vector classifier. So, they use Freeman chain code for extracting features and also use private operator. Next paper is feature extraction methods for character recognition. This is basically a survey. They presented overall overview of feature extraction techniques for binary, contour, grayscale, and skeleton images. They give types of methods so we can use for extracting features like template matching, deformable templates, unitary transform, zoning, geometric moments, dynamic moments, template matching. Yeah, that's it. So the next paper is feature extraction based on DCT for handwritten digital recognition. So they use DCT for feature extraction and they use MNIST dataset and they applied SVM classifier. So talking about the research there, so most of the existing research are only based on one or two algorithms, and most of the people used convolution neural network for OCR, and there are not so much combined algorithms for specific recognition of characters in Devanagari system. Next is that we compared classifiers, all the accuracy of all the classifiers, and we did a comparative study of all the classifiers and all the algorithms. So next is talking about the novelty. We use scale invariant feature transform, that is SIF, discrete cosine transform DCT, and histogram of oriented gradients, that is HOG, and we also use combination of all these three feature extraction techniques, that are we use SIF plus DCT, SIF plus HOG, DCT plus HOG, and HOG plus SIF. And we did the comparative study of all these, means SIFT plus DCT, DCT plus HOG, HOG plus SIFT, as well as we compare all these methods with SIFT, DCT, and HOG individually. And we used 3 to 5 classifiers. We will discuss that later. So talking about the methodology, first is that dataset. Our dataset is consisting of Devanagari characters. Then we do binarization on the dataset. That is, we apply thresholding and we transfer the pixel value to either 1 or 0. Next is noise removal. We use Gaussian blur for removing the noise, removing the small noises that present in images after thresholding. Next is feature extraction. We use SIFT, DCT, and HOG for feature extraction, and then we apply classifiers that are decision tree, support vector machine, KNN, random forest, and LGBM. And the last part is of recognition. Next part is dataset and pre-processing. So the dataset for our project is created by our own. So we take 300 images of every character, that is total 36 characters of Devanagari system. So there are 36 classes. Every image is resized to 64 cross 64 pixels because for each in recognition purpose, and then we converted images to binary, and after binarization we apply Gaussian blur for removing the small noises from the images which are obtained after thresholding. Next part is feature extraction. First, we will talk about scale invariant feature transform. So features are detected by analyzing the pre-processed image at different scales and orientations. So once features have been detected, they are described in terms of their visual properties. After this descriptor is generated for each feature that capture its unique visual characteristics. Next, a subset of features is selected from the available data. The goal is to choose the most relevant and informative features that will help the machine learning algorithm to make accurate predictions. We save all the feature vector in CSV file after applying the shift on all 36 classes. Then we combine the CSV file of all 36 class. After this, for the dimensionality reduction process, we use k-means, where we reduce a feature vector of 128 into 8 clusters and then save the new CSV file. Our generated feature vector for the shift is of size 204876 into 128. So we will reduce that using k-means clustering. This is the steps. First we take input images, then pre-processing, then we extract the feature vector, and then we will apply k-means with k is equal to 8, and then we get a reduced feature vector, and then we save that in CSV file. Discrete cosine transform divides the image into blocks of pixels, and then it applies the DCT to each block independently, and then the DCT produces a set of frequency coefficients for each block. Below is the algorithm for the same. First of all, we will take all input images, that is 10,800, and then the output for this algorithm is to get a feature vector of size 10,800 into 15. So we will look at the steps of this algorithm. So first of all, we give them path of images, then it takes every images in dataset and the rescale is to 64x64, and then it computes DCT features, then it normalizes the extracted features, and then we implement principal component analysis. So the components we take here are 15, and then we close this loop, and then we append all the information that we got from the discrete cosine transform into a CSV file, and it returns a feature vector of size 10,800 into 15. Next is histogram of oriented gradients. So here we divide the images into small and overlapping cells, and we compute the gradient magnitude and orientation for each pixel in the cell. So now we will look for the algorithm for the cell. So here also we take images, all images, that is 10,800, and then we will look into steps. That is, first we give a path of images like DCT, and then we take every image and rescale it to 64x64 and implement HOG. And after implementing HOG, we get high dimension. We get picture vector of very high dimension. So for reducing that, we use principal component analysis with components of size components, 15 components, and then we end the loop and append all the extracted features to CSV file, and finally we get the feature vector of size 10,800 into 50. So next is combination of algorithm. This is one part of our novelty. That is, we combine all the algorithm, that is shift, DCT and HOG individually. That is shift plus DCT, shift plus HOG, DCT plus HOG. So this flowchart shows the feature vector size and the feature vector size after adding different algorithms with each other. For the classification purpose, we use decision tree, separator machine with RVF, and polynomial kernel with 2 and 3 degree. We also use KNN, random forest, and AGN. As you can see in the table, we get the highest accuracy of 98.7 by using extracted features of discrete cosine transform and applying the support vector machine classifier with polynomial degree, with kernel of polynomial of degree 3. We can see here that DCT individually gives the accuracy of 98.7, and the other combinations and other algorithms are not that much efficient like DCT. In future, we can say that we can implement cloud-based recognition service. There are some latest in Devanagari characters like M, B, G, D, which are identical, so they use error sometimes. So for that, we can use CNS-based approach with Zenith moments, and we can also use the fusion of DCT is one of the above, which will give more accurate results in such cases. Now for concluding, we can say that DCT is more efficient than other algorithms and other combinations of shift and HOG, and individually shift and HOG. We recognize the factor successfully, and The different algorithms need the different preparation techniques. And finally, I can say that combination that we tried, like shift plus DCT, shift plus HOG, it is also not much efficient than DCT. Yes, that's all. And these are the concepts. Finally, we would like to extend our sincere gratitude and thank the reviewer, organizing committee members, and respected session chairs of the ICACIS 2023 for giving us opportunity to present our paper.
Okay, I have one question. What are the relation between accuracy and precision value?
Sir, precision value is that first of all, while predicting, we create one table that is true positive and false positive. So that value gives precision accuracy and precision value, and then accuracy is calculated by using precision and recall value.
You have used PCA 15 only. Can we increase the PCA value?
Yes, sir, we can use, but for reducing, what is the goal of PCA is that we want to reduce the dimensions of the data set, dimensions of the expected features. So that's why we take it 15. We can increase it.
Okay, thank you. It was a nice presentation. Nice work. Keep it up.
Thank you, sir.
So which two algorithm you have hybrid?
Sir, we use DCT, SIFT, HOG, and also we use a combination of all three, that is DCT plus SIFT, DCT plus HOG, and SIFT plus HOG. But for the outcome,
feasibility study you have made before you make it hybrid?
What, sir?
Any feasibility study or any feasibility analysis you have done before you make it hybrid?
Yes, sir, we did the study, but what we think that after combination, we think of that we will get incorrect accuracy. But what we found is that after merging the two algorithms, what happens is that the accuracy is lowering significantly. But DCT along as a single player, we can use a higher accuracy compared to other, which is 98.7 in our case.
Okay, thank you.
Thank you.
Thank you, sir. Now, next presentation, we have the paper ID 4035. Paper title is Optimizing Pneumonia Diagnosis through Local Binary Pattern and 2D Wavelet Transform Based Feature Extraction and Classification.
I am Rahul Gautam Pula, PhD scholar working under supervision of Dr. Shivashankar Sir, Department of ECE, SRM University, AP. Today's talk is on optimizing pneumonia diagnosis through local binary pattern and 2D wavelet transform based feature extraction and classification. Contents of today's presentation are as follows. X-ray imaging. It is a non-invasive medical imaging technique to create images of internal structures of the body, like lungs. It is a fast and effective diagnostic tool, but it is limited in its ability to distinguish different types of lung infections, like bacterial or viral. It is only a preliminary diagnostic tool that should be validated by blood and sputum tests. X-ray imaging has improved over time, resulting in better image quality and more access to open source dataset for research. Feature extraction algorithm. It refers to extracting relevant and informative features from raw image data. It is a process of computing a set of numerical values or features that describe the visual contents of an image. It is essential when raw data is complex and of high dimensionality. The two key feature extraction techniques used in our research are 2D wavelet transform and local binary pattern. It is highly advantageous as it speeds up the training process and also reduces the risk of overfitting due to small dataset. 2D wavelet transform. The framework of 2D wavelet transform based feature extraction and classification is presented here. Initially, we collect the dataset, we pre-process the data, we apply 2D wavelet transform to extract features from images, and those features are used to train classifiers. Using classifiers, we classify the test images into pneumonia and normal class. The 2D wavelet transform algorithm implementation is as follows. First, we import libraries, we specify paths to dataset directories, we read and pre-process the image into a grayscale format. Then we apply 2D wavelet transform using HAR wavelet. We extract features like approximation, horizontal detail, vertical detail, and diagonal detail. Then we flatten and concatenate coefficients into a feature array. Now we create labels for respective classes, in our case pneumonia and normal class. Now we combine the feature arrays and labels to create a data with corresponding labels. Now the data is split into training and testing data sets. Using multiple classifiers, we train them and test them to classify the test images. The performance of classifiers is evaluated by standard evaluation metrics. Here we present the 2D wavelet transform representation of different coefficients corresponding to different subbands. The subbands used in our 2D wavelet transform analysis are approximation subband, horizontal detail subband, vertical detail subband, and diagonal detail subband. Number of coefficients corresponding to multiple subbands are presented in the table. Local binary pattern. The framework of local binary pattern based feature extraction and classification is presented here. Initially, we collect the data set, we pre-process the data, we apply local binary pattern to extract features. Using those features, we train the classifiers. The classifiers are used to classify the test images into normal class and pneumonia class. Local binary pattern algorithm implementation is as follows. Initially, we import libraries, we specify path to dataset directories, we define the parameters of LBP algorithm, which include radius and number of points. We then read images and create labels corresponding to different classes of images. We combine image list and label list to form an input data. We split the data into training set and testing set. We extract LBP features from training set. Using this, we apply LBP algorithm on all images. We compute histogram of LBP patterns. We append histogram to testing feature list. After extracting LBP features, we convert feature list into feature arrays. We train the classifiers and test them to classify test images. The performance of classifiers is evaluated by standard evaluation metrics. LBP feature vector. It is a representation of distribution of local binary patterns across an image. It captures the frequency of different local binary patterns. Each element of the feature vector corresponds to specific LBP patterns within an histogram. LBP histogram. It provides summarized view of distribution of local binary patterns across an image. It represents the frequency of each LBP pattern in the form of a histogram, where x-axis represents the number of local binary patterns, whereas y-axis represents the frequency of local binary patterns. The LBP representation of an X-ray image and its corresponding histogram is presented here. Classifier. The classifiers used in our research are SVM, random forest, naive Bayes, KNN, and logistic regression. SVM classifier. It finds best hyperplane to separate data points from different classes. Random forest. It is an ensemble classifier that combines multiple decision trees to make predictions. It improves accuracy by reducing overfitting issues. Naive Bayes classifier. It is a probabilistic classifier based on Bayes theorem. K nearest neighbor classifier. It is a non-parametric classifier that assigns label to data points based on neighborhood of that label in that feature space. Logistic regression. It is a simple and interpretable classifier that models the relationship between input features and the probability of certain outcomes. Performance metrics. The standard performance metrics used are accuracy, precision, recall, F1 score, and area under the ROC curve. Accuracy. It measures how well model performs across all classes. Precision. It is a measure of how many instances predicted as positive are actually positive. Recall. It is a measure of how many actually positive instances are correctly predicted as positive. F1 score. It is a harmonic mean of precision and recall. Area under the ROC curve. It shows performance of the model by taking all classified thresholds into account. The performance evaluation metric results of all classifiers corresponding to local binary pattern and 2D wavelet transform based feature extraction and classification are presented in this table. This slide presents area under the ROC plots of local binary pattern based feature extraction and classification, and also 2D wavelet transform based feature extraction and classification. This slide also presents the performance metric comparison of LBP and 2D wavelet transform algorithms. In this talk, we presented a novel 2D wavelet transform and local binary pattern based feature extraction and classification framework for pneumonia diagnosis. The classifiers exhibited better performance results compared to existing work. It has potential to be implemented on hardware FPGA designs for real-time diagnosis. Future work has scope for improvement in different wavelet bases to enhance performance results. Here are the references used in our research. Thank you. Thank you for this opportunity.
Okay, so I have one query.
Yes, sir.
So I am seeing your references. There are no references from year 2023. First of all,
Yes, sir,
even though it's a good presentation. What is the sample size for your research?
Data set sample size.
Data set, yeah.
13,000 some 478 images, out of which 10,000 were affected and 3,000 were normal. We have chosen more affected data size.
So from where you have taken this data?
Kaggle dataset, which is open source data source for most of the COVID, pneumonia, X-ray based any applications. That is source. They'll have even the patient background, like other disease history also. It will be a CSV file where you'll have other supplementary disease information also.
Which model you have used for feature extraction?
Local binary pattern and 2D wavelet transform.
Okay, these are the two models. No?
Yes, sir.
Okay.
I have seen one AUC you have calculated.
Yes, sir.
What is the role of AUC?
So basically, area under the ROC curve, it considers all threshold patterns of all the classifiers, and it will place it in the form of a graph. Like if our plot is completely linear, it is only getting 50% accuracy. If it is going to an exponential high and it is getting saturated, it means our results are like on top threshold. If it is in below the half of the linear part, it becomes like our model is very low. It is not performing well. This is the 3 stages of AUC: saturation, linear, and bottom part.
Any impact on accuracy?
So accuracy is a separate metric, like precision, F1 score, sensitivity, selectivity, and AUC. These are separate. Like measure parameters are different. So formula is also different. We'll consider different metrics for different.
Okay, thank you.
Thank you, sir.
Thank you, ma'am.
Now, next presentation we have. Yes, sir.
Just go quickly. Just go quickly. Huh?
Sure, sir. Sure. Yes, sir. Next presentation, we have the paper ID 4694, and the title of the paper is Artificial Intelligence Based Optimized Traffic Diversion System in Smart Cities. Through sir, please skip some part after the introduction.
Very good morning. Okay. Myself, Dr. Sachin Sharma, and I'm here to present the paper title Artificial Intelligence Based Optimized Traffic Diversion System in Smart Cities, and paper ID is 4694. These are the contents that I'm going to cover in the presentation: introduction, literature review, proposed methodology, implementation, result analysis and discussion, challenges, future perspectives, conclusion, and references. As we know that traffic diversion system is very important when the smart city is the concern, that employs artificial intelligence algorithms to improve traffic flow, and it also helps in reduce the congestion. There are objectives to provide real-time routing recommendation for moving cars depending on the flow of traffic in order to cut down the travel time, fuel consumption, and enhance the air quality. There are a number of authors had recognized this problem, and they worked on rerouting of vehicle and that help to increase the traffic flow. There are also other authors who worked on the recommending better routes for each vehicle based on the traffic data. And there are some authors who worked on the traffic management, context aware, and multi-objective rerouting algorithms. This is the data flow for the traffic prediction. When real-time data is collected, that is passed to cloud environment for data transmission, and then data processing happened on cloud environment where traffic prediction will be done. Then that traffic prediction can be visualized in real time by the user. This is the flow chart of the proposed methodology. We start and we fetch the current position of each individual vehicle, and it is asked by each vehicle what's the destination. Then identify the number of curves and hilly road, then the blind spot. If the number of curves are 0, then that system will stop. working. Then if there are number of curves, then it will identify like how many curves are there and how the vehicle can be rerouted based on the available routes and the safety of the driver and passengers. And the distance will be estimated, what is the closest one, and then it will display the route. It's a comparative analysis table where we can see that many authors, they worked on current signal plan selection system. They also use deep reinforcement learning, AI based system, energy efficient optimized path discovery, improved visibility on curve, hilly road using Internet of Things. In this paper we have used deep learning and artificial neural network. There are the following challenges that we see in the proposed methodology is data quality, privacy is the concern, algorithm bias, cybersecurity, public acceptance of the proposed model, and the infrastructure limitations. These are the future perspectives that proposed methodology will be helpful to reduce the traffic congestion, improve travel time, better air quality, efficient use of resources, and enhance safety. In conclusion, we would like to mention that real-time traffic prediction involves estimating the present and future levels of traffic on roads and transportation network using data and algorithm. And here we have goal to provide the safe transportation system. And machine learning algorithm like neural network reinforcement learning can be better technology to access the data in real time and do the traffic prediction. So these are the number of the references that is being used. So here are the rest of the references that has been referred to develop this content. Thank you so much.
Okay, so Sanjay, first of all, just tell me how you have collected the data basically.
So data
vehicle monitoring.
collected real time through the
Real time.
sensors and the drones. So through the sensors and the drones.
Which sensors is used basically? Which sensor you have used? Basically, it's my area of research. Basically, my PhD in that particular topic.
So, sir, actually, this work is done by my mentor. You can share me your contact details. I will surely get back to you on this.
You just tell me how you have collected the data.
Sorry, sir.
And which simulation tool you have used for that?
Sir, can you?
How you have implemented it?
Sir, we have collected the data and it will gather the current traffic information from a variety of devices.
First of all, if you have collected the data, means how you have collected the data?
So
there must be some method.
Data deployed in the, sir, in
You are telling that your data is on cloud.
Yes, sir. We will transfer the data into the cloud.
How you will transfer? Which communication technology we will use to transfer data from vehicle to the cloud?
Actually, this work is done by my mentor. I don't have that much idea.
You must have an idea when you are presenting a paper in international conferences. Okay, thank you.
Okay, thank you, sir. Now, next presentation we have the paper ID 4765. Paper title is Integration of IoT and Industry 4.0, Revolutionizing Industrial Process. Presenter name is Anish Pradeep.
Hello everyone, my name is Anish Pradeep from Tashkent, Uzbekistan. Thank you for giving me the opportunity to present my paper. Topic is Integration of IoT and Industry 4.0, Revolutionizing Industrial Processes. To introduce my topic, the main idea of this paper was to find how IoT can be integrated in Industry 4.0 so that large corporations, factories, and companies can be more effective, more productive, as well as be more intelligent or smart factories. And we'll also go in detail with some examples how IoT and 4.0 has transformed traditional manufacturing processes. So before that, we need to have a look at what problem we are trying to solve. There are different factories that works with different vendors and they use several components, and there should be a way so that all the components and all the sensors and all the security and communication protocols be monitored, and there should be a platform so that they should have real-time feedback from these components so they can make quick changes or quick updates. IoT and Industry 4.0 also will be looking at the scalability issues, how fast it can be implemented and scaled within industries. Because as you know, the number of IoT devices keeps on going, and most of these devices are connected to the internet, and there should be a system so that all this data being generated should be able to easily gathered and also analyzed, because there's no point of wasting energy for collecting all the data if it's not being analyzed in a useful way. To address this, we'll be examining difficulties in integrating Industry 4.0 and Internet of Things, including standardization, scalability, and security, because there are some issues for easily implementing these methods. So Industry 4.0, I think it's a new term being very catchy and being very popular. I want to explain this with the help of an image. So as you can see from the first, second, third, and fourth generations of industry, we are moving towards more smart systems. We are moving towards systems with a lot of computer systems as well as digital sensors, so that the factories and companies can make quick decisions, quick data collections, and quick updates to the system. And the system is being more efficient, as you can see from the picture. From the first and second generation, most of them are very manual, and moving to the third and fourth, more automation and less humans are involved. So as we always say, when there are less humans involved, there are less error occurred in these systems. So why it's important? It's not only about being automating tasks, but also creating intelligent, connected, and highly efficient ecosystem. Means there are a lot of different components, as I said before, from different vendors, and we should be able to combine all of them to work as a cohesive ecosystem and communicate with each other. IoT is a new trend, again, not a new trend, for the past maybe 5 or 10 years. All the components are able to communicate between devices and also communicate through internet, so that manufacturers can collect real-time data from every aspect of the production process, from raw materials to the finished products. Even after finished products, these systems can be used for supply chain management and supply chain efficiency. IoT sensors can also track the performance of the machines and equipment in real time, spot anomalies, and even can use AI to forecast or foresee issues and maintenance if necessary. There are various industries where IoT and Industry 4.0 are being used a lot. Smart manufacturing, predictive maintenance, asset tracking and management, quality control, and supply chain management. Let's look at the benefits of IoT and Industry 4.0. Improving efficiency and productivity. So being able to collect data as well as predict the maintenance in the future, the industries can create products more efficiently with less cost, which comes to the second point, reduced cost. So if the companies are able to mitigate future issues with machines, predict anomalies in the system before any issues happen, it can greatly reduce the cost. Better quality control of the products, not only the final product, but also the process in which the product is made. So the factories can have several sensors and collect real-time data and feedback from these sensors as it goes through the pipeline. Increased safety. There are various IoT sensors being developed and being used in various parts of the factory, not only to protect the employees or the factory workers, but also for not damaging the devices, such as heat sensors, vibration sensors, pressure sensors, from, let's say, not even exploding, and also to save factory workers. And finally, real-time data analysis. That is what the main core part of the system is, to provide a real-time analysis so that the industry, which is of 20 years, overclockability devices can data integration platforms, various platforms where there is a need of providing common protocols so that the IoT devices can. A few examples, a few smart manufacturing use cases. Predictive maintenance, as I said before, is a practice of using data and analytics to monitor the performance of equipment and predict any maintenance required. Second one is real-time monitoring of the manufacturing process and also control of production lines, and various sensors can be used to measure temperature, humidity, vibration, and energy consumption. Then we have supply chain management, where real-time tracking of materials and products throughout the supply chain can be used, so they can be optimized so that the future costs can be reduced. And finally, automation and robotics to optimize the manufacturing process and reduce the need of manual labor, because these devices don't get tired. They can work 24 hours, but we need to make sure that there is quality control and a proper maintenance of these devices by using sensors and data analytics. Data analytics also, it's been revolutionizing manufacturing business. It collects large amount of data from maybe hundreds and thousands of sensors from a factory, and it is used to do real-time analysis and decision making. So to conclude this presentation, industrial processes have been transformed by integration of IoT and Industry 4.0, because this is needed for the manufacturers to cut waste and improve the product quality by reducing the cost also. Real-time monitoring of manufacturing process also made by using IoT sensors, and the data collected and the data is analyzed by experts so that maintenance can be predicted, and it promotes high efficiency and lower downtime. Thank you very much for this opportunity, and please let me know if you have any questions. Again, thank you.
Okay, it's a nice presentation. I have one question.
Yes, sir.
Basically, now at a time we are talking about Industry 5.0, but you are still on Industry 4.0. Why?
This is so main idea is this paper was like a review and a feasibility study for let's say underdeveloped nations. There are nations where, due to the cost constraints or the knowledge of technology, these kind of even industry 3, they are still in industry 3.0. So hopefully this paper will give many industries such as healthcare and also hospitals to include technologies so that they can be more efficient and also save cost and time.
Okay, one more question. What technology basically are used to implement IoT?
Let's say from a testing point of view, most IoT experiments are usually done by using Arduino, or they have ESP32. Even me and my team, we made a small low-cost fire detection method where for agriculture, the farmers can use this very small, lightweight, low-power ESP device that can connect through small sensors, and the data is being sent to the server without any internet or 3G by just using a LoRa technology. So the main idea is to provide solutions that can be implemented easily and low cost, so that to answer your question, one option is Arduino. I was just explaining the project that I was working with. We were using Arduino and ESP32.
Okay, thank you.
Thank you, sir.
Thank you, sir. Now the next presentation we have the paper ID 7059, development of facial emotion recognition system using unimodal and multimodal approach.
Madam, how many presentation we have remaining?
Sir, we have only 4 presentations.
Okay, thank you.
Okay.
Here I am, Shwet Kranti Thavre, presenting topic development of facial emotion recognition using unimodal and the multimodal approach. So I have submitted a paper for the conference on the advanced automation and intelligence system. So my content for this presentation related to the emotion recognition. So what is the need of the facial emotion recognition? Then again, what type of the facial feature extraction techniques are available? How this facial emotion recognition can be used with the help of the deep learning. We can achieve more accuracy, and at last we will see the point like as emotion recognition with the context awareness. The first thing when we start with the emotion recognition, there will be different applications where emotion recognition will help more, as we consider, like as in healthcare applications also. In our getting in healthcare application, we are predicting giving some recommendation about any disease prevention. And also why we are using only here I am in this paper, I am focusing on the face only. I have taken start from with a one model only, that is what a face. So why face? The face is nothing but a multi-signal approach actually. So as far as the face we consider, as we have the 5 sense of organs which are present on the face itself also, it's like as a nose and eyes and everything. So we'll get most of the signals from the faces, and we know that by seeing the face we'll get the more emotions. So I start with the first with the face emotion recognition. So when you consider the face, we have to get some movements of some facial movements. We need to get a measure of these facial movements. So first of this is what there are 2 methods actually, that is message judgment approach and the sign signal based approach is there. So when you consider the sign signal based approach, it is related to the emotion related approach, where we have just seen the movements of the faces and we are calculating the emotion on the faces. There are some 64 facial units are there. And that as far as these facial action units, we will judge that which emotion is related to that facial action units. Then again, if you consider, and this is what I mean to say, why we are moving towards the facial emotion recognition. Then I have created one table that is to get to know about the current updates about the facial emotion recognition. So I start with the facial emotion recognition. They have started with the different, starting with the images, facial images for small type of the images, like as a small number of the images. The work has been started. They use some of the authors uses what the LBP technique, some of the author uses only the Hawk feature extraction technique. Then they applied the machine learning algorithm. So I have identified everything by the survey table, and I got this. I need to get to about not only one model we need to consider for the emotion recognition. We need to consider the different modalities of the different modal. Like it's not only face, you can consider also the other modalities, like as what you were the gesture, then body movements, and then text. So we need to convert that also. So this is related to about the literature work. I have identified the number of gaps, and again, if you have, I just started with the studying these things. Start from the only one facial movement. So there are as in facial images level now, that is histogram oriented gradients, then local binary pattern. Getting this, whenever you apply this HOG, get the direction also. So after getting this gradient, we are just mapping this gradient to the bins by different methods, and we are constructing the histogram of this all the bins. And as far as the bins, we are getting this whenever you apply this HOG on the CK plus 48. If you see this figure, you will get this is the original image, and this one is what you will get the HOG facial descriptor. So when you see this HOG facial descriptor, we did not find the image clearly. You see this, and after this feature has been extracted, we are applying the sequential model, and it just gives only the 61.92 accuracy for the 5 number of epochs. I have taken consider only the less number of epochs to get to easily execute the my first sequential model. You can increase the epochs also, and after that, we are applying the same thing on the CK plus 48, that is what the local binary pattern, where we are just finding the intensities of a different of middle pixel with the surrounding pixels. Then this wherever you have a middle pixel which is represented by some LBP hole, and the other pixels values are just surrounded with the 0 and 1, then we'll get a LBP code. And after applying this LBP on the CK plus 48, you will get this LBP facial descriptor. Here will increase the, if you can see the original image and sample image is there, and somewhat you're getting the facial And that is feature which we just use the 68.52 training accuracy for the 5 number of epochs are there. So this original image is there, and we are getting this LBP facial descriptor. So the accuracy has been increased inside in the LBP. That is what a local binary pattern. Then again, when you consider the scale invariant feature transform is there, when you apply it in SIFT is applied actually on the 7 points on the face, and you will get this facial SIFT filter feature where you get the accuracy is somewhat closer to the LBP. Then again the other technique, that is what the Gabor filter which has been applied on the CK plus 48, then it just gives this filter feature. It is very clear image you will get. So and getting the accuracy that is 86% by applying this Gabor on the CK plus 48. So from this we can conclude that Gabor filter gives the more accuracy. And when you see this is the actual table. We are comparing their accuracy of the for the 5 epochs. So without any feature applying, we are getting the 83%. So other than we are getting more accuracy, if you are not applying anything, consider by comparing SIFT, LBP and HOG, this gives the better accuracy. So this was the one of the approach of what a unimodal. And when you consider only simple size, that small size of the as the CK plus 48 contains only 981 images are there, by considering all the levels of emotions, then it is very less. So we need to consider the more training samples to model this. To get to recognize the emotion. So I consider this in the next thing, I consider one more data set, that is what FER 2013 data set, where it has a number of training samples and it is in thousands in a training and testing samples are there. So when you apply the CNN, as we have a number of images, we need to apply a deep learning technique. So I started with the CNN model and it gives this accuracy, that is what 91% accuracy. And when you consider the same CNN which is applied on the RAF DB data set, it will give the 87.21% accuracy. Then this is regarding about the FER 2013 dataset and RFID dataset, where you get more accuracies when you apply your deep learning. Now, this is what only the recognize the 7 basic emotions. When you need to consider about the context awareness, we need to consider one of the dataset, that is emotive dataset, where it consists of the 26 emotion categories with the 3-dimensional categories of the valence, arousal and the dominance. Again, here we'll get the average precision for a more coverage of the emotion has been recognized by using emotive dataset. So by concluding at the end of this, we just conclude this is Gabor filter produces results that are superior to those produced by the other approaches. As the training samples increase for getting more accurate result, we need to use a deep learning. And the third one, if you want to know the more emotions, you have to use not only a new model emotion recognition, not only one phase, you have to use a different modality emotion recognition. As we see the emotive dataset, we have the annotation for the 26 emotions. Not only 6 emotions, 26 emotions. Most of the plectric will emotion has been covered by using emotive dataset. And I have referred this all the papers for to know about the research that is undergoing. And lastly, yes, good afternoon.
Okay, it's a nice presentation. How many sample size you have taken?
Sir, I have taken total 4 data sets. This is one first data set is what a CK plus 48, where I have only
sample size.
Yeah, 981 images are there only. 981 images are there. It is in KB only. Size of the data is in KB. And about FER 2013, there are 30,000 is used, about 13,000 used for training samples, and 3,000 will be for testing, and 3,000 will be for validation. And another dataset is what emotic dataset, where we have taken 2 models, that is what the body gesture and the facial. So again, it has it's about 27,000 images are there for facial images, and same the images there we have just extracting the body gesture.
The data is taken from which particular data sources are from?
This is from Kaggle, sir. Emotic data set is there, and also CK plus 48 also available from the Kaggle.
FER 2013 is also available in the Kaggle.
What is the accuracy of your particular result?
Sir, it is about in terms of what if you compare the deep learning neural network, it is about 91% accuracy. When you have n number of images, more number of images are there, then you need to apply deep learning, and deep learning model gives me the 91%. I just applied the sequential model, sir.
Okay, you have to need the accuracy of your model, na? You have to refine it if you are working on it.
Yeah. I have to work actually by using some optimization technique where I get the subset of optimal features, sir.
Okay, thank you. It's a nice presentation. Best wishes.
Yeah. Thank you, sir.
What is the neuroscience part?
Yes, sir.
What about the neuroscience part in your paper or research?
I'm not getting questions, sir. Please, sir.
Do you have any neuroscience part?
Neuroscience?
Yes.
No. I have not considered that neuroscience. I mean, I have to consider the EEG signal that you want. EEG signals.
Sir, अपने यहाँ से डाउन रखिएगा.
Yes, sir.
Yes. No problem.
Yeah. Okay. Thank you, sir.
Thank you, sir. Thank you, ma'am.
Thank you, ma'am.
Now, next presentation we have paper ID 7270, real-time face recognition for biometric attendance using convolution neural network.
Hello, very good morning. ICACIS 2023 team. I am Pooja Katke. Today, I am going to present a paper on real-time face recognition for biometric attendance using convolutional neural network under the guidance of Dr. Mrs. Rupali J. Shekhe ma'am. And my paper ID is 7270. We will discuss today these points: introduction, then literature review, then we will discuss methodology, results and discussion. At the end, we will see conclusion and the references. First, we will see introduction. Deep learning is widely used in image recognition due to its strong feature extraction ability and high recognition accuracy. Face recognition is achieved using deep learning subfield, that is convolutional neural network. The human face is sophisticated multidimensional structure that can convey a lot of information about individual, including face expression, feelings and facial features. CNN is a category of neural network architecture which extracts the feature implicitly without any prior institution, in contrast to convolutional machine algorithm. In this paper, we are doing face detection, face alignment and face cropping. Also, CNN is used for the extracting features from the images. Maintaining attendance is very important in all learning institutes for checking the performance of students. Marking attendance on the sheet manually is very time consuming and inaccurate, as some students often sign for their absent colleagues also. This method also makes very difficult to track the attendance of individual students in a large classroom environment. In this paper, we propose the design and use of a face detection and recognition system to automatically detect students' attendance by recognizing their faces. We are taking here students' picture with different feature expressions, and we will store this data in database. And at the end, we will compare the obtained results with database we have maintained. Then we will discuss literature review. We have seen 2000 attendance through the face detection, face recognition in this video. They have created a video for this. Implementing the previous software can be used for recognition. The IGEN-face and paper is attendance management system can keep the track of daily attendance, working hours and login and logout time also. It prevents the staff time theft. Then next is methodology. In this paper, first of all, camera will capture the images of the students, and images are input to the Python for the further processing. That is, input image is camera captures image of node and is fed to input to the Python for further processing. Then pre-processing. Pre-processing images commonly involves removing low frequency background noise, normalizing the intensity of the individual particle images, removing reflections and masking the portions of the images. Image pre-processing is a technique of enhancing data images prior to computational processing. This is the technique of enhancing data images. Then feature extraction. Feature extraction involves reducing the amount of resources required to describe a large set of data. When performing analysis of complex data, one of the major problems stems from the number of variables involved. It involves reducing the amount of resources required for large set of data. Here, wavelet transfer to extract features like RMS value, average and entropy of the images. CNN classification. It classifies each pixel into one or more classes given a set of real-world object categories. Image classification refers to the task of extracting information classes from two or many classes of the images. CNNs are used for the image classification and recognition because of its high accuracy. And finally, the obtained image is compressed with the database. Faces are made of thousands of fine lines and features that must be matched. The face recognition using Python breaks the task of identifying the face into thousands of smaller bite-sized tasks, each of which is very easy to face recognition using Python, the latest in this machine learning techniques. Each picture is centered on a single face and every image is encoded in RGB. The original images are of the size 250 by 250. The main components of a facial recognition systems are face detection, landmark detection, liveliness detection, face recognition module, etc. Face verification is the process of verifying that a given face corresponds to a specific person. Face recognition is the process of identifying a person from a given image. While face detection trains a computer to pick out from a human face, face recognition software will analyze the image properly. This is all about methodology. Then results and discussion. Deep learning is based on a deep neural network and a branch of artificial neural network. And now we can see here three images. Each one is first one is showing the final output, and it will be in the format of Excel sheet. And Excel sheet has a date, time and student's name. Also for present student it will noted as P, and for the absent student it will noted as A. If one of the student is not present in the database, then the image is named as unknown image. If the student data is present in the database, then the image is named as per their respective names. That is in result 2 we can see Pooja and Sanjay both for the image for both the faces database has already stored. That's why the image is showing as named image as Pooja and Sanjay. And in the result when the data is not stored of particular face, then it is known as unknown image. Conclusion. Finally, to change the traditional system of the taking attendance, we have used this project. This is a very reliable, secure and fast and efficient class attendance management system has been deployed for replacing manual and reliable system. Facial detection is influenced by the clarity of the image. Facial recognition is a category of biometric software that maps an individual's face features mathematically and store the data as a face print. It has better security and it is very easy to integrate automated identification also. It is a fast, reliable and secure the attendance monitoring system to replace manual and reliable system. It will save the time and reduce the work. Also, I want to tell the facial verification. What is the two main types of facial recognition? The primary difference between facial verification and identification is the type of technology uses one-to-one matching and one-to-many.
Can you
That
stop
is
the
facial.
presentation? I have some questions.
Yes, sir.
I have some queries. Okay,
Yes, sir.
just end your presentation, Anna.
Yes, sir.
Okay, what is the novelty of your work? There are a lot of work has been done already on attendance system, biometric attendance system. Anna, what is the novelty of your work? What is new in this?
Actually, images of each person can be of any size, and at least I have taken 10 images of each person, and we have used here 3 layers of CNN. That is 2 convolution plus sampling layers. One is for fully.
There is already there are a lot of work on CNN based biometric attendance system. What is the novelty of your work?
So there are different types of database also present in the database. I have taken more 900 about 900 faces in databases.
Even in I have seen the latest paper, people have taken more than 10,000. You are still working on 900.
This is a real-time face recognition process. So
every system is real time, my dear. What is the novelty of your work? What is the new in this?
So
okay, thank you. No more question from my side.
Okay, thank you, ma'am. Now, next presentation.
Is it
Paper
the
ID
last
is
one? Is it the last one?
Sir, this is the second last. Next paper ID is 9763. The paper title is An Approach for Efficient Expert Selection in Team Formation Problem. Presenter is Sandeep Shingare.
Good afternoon all. My name is Sandeep Shingade, research scholar from IIT Roorkee. Today I am going to present my research work, An Approach for the Efficient Expert Selection from the Team Formation Problem. My paper ID is 9763. Okay, so outline from my presentation, we discussed the introduction, literature survey, preliminary, proposal architecture, and future of work. Team formation. What is the team formation? Why we require the team formation? So if we say that any complex task, this task will be performed the single agent. It is very difficult and time consuming to complete this task. So same task from we have to apply the different multiple expert of the agent, which can be solved significantly with specific deadline. So this task from the selection of the problem from the team, it is we say that it is a NP-hard problem. That is, we say that it is exponentially problem, and this problem we can solve with the meta-heuristic approach, or we have to solve the parallel computing. There is some other problem is also there. After assigning the team, there will be some agent want to leave, so we have to give the chance to they have to leave, and then we have to find the efficient replaceable agent from that particular team. So these two approach we have to use. That is, we have to find the most optimization team to perform that particular complex task, and if any agent will be failed, we have to replace that agent with the same specified skill. What is the significance of the team formation problem? We say that team formation problem, we have to from the selection of the player in the sport, like a football team, we have to use the attacking player, defending players. We have to give the priority from the most attacking player, from the poor player, defending player, that is poor player. So this task, we have to best player from that particular from the team formation problem. Similarly, from the employment requirement, we have to find out the one job with the 1,000 applications, and we have to find the best suitable employee from that particular post. So this NP-hard problem we can solve with the some approach. From the related on the team formation problem, we have to refer some literature survey. That is the first author from the refer number 60. Algorithm. Refer number 6 will give the new optimization model from the possibility that if any reliable agent will be used. This is also happening from the reliable. So this is some literature survey from this our problem. Our approach, we have to use the O2 approach, that is a task oriented project where the agent will be selected based on their performance, and their performance we have to find the subset of the expert to optimize the priority task. We have to consider their gradual performance from the average, and we have to find the determine the interaction factor with the heuristic approach using the equilibrium distance. So proposed system also we have to use the handle the uncertainty. Any agent while we fail, we have to find the efficient replace agent to that particular team. So this data approach, we have to use the two data set, that is expert data set and task data set. And we also demonstrate the rootedness if creating team the task rootedness property, and the task is efficiently performed when there is unexpected change in the composition. So our approach is successfully designed from the optimization of the team with the coordinator, and after selection from the task 1 to task 2, we have to select the best possible average performance agent to that every individual task, and then remaining from the task 1 from the 10 expert, we have to find the remaining 9 subset of the expert, that is we say that remaining expert 9. So we have to reduce the 1 expert from the every task, and then we have to find the subset of the expert. Some preliminary, that is we have to find the equivalent distance from one agent to another distance with the there is a graph coordinator formula. Then we have to find the task 1, so task 2 is require the 5 experts, we have to find the 5 agent with their confusion matrix of the equivalent distance. So E1 will be give the E2, E3, E4, that is there is the equivalent distance. So we have to choose the minimum equivalent distance from this task. Similarly, E2 to E5, E3 to E5, all they have to discuss. We have to go from the direction proposed, so that we have to give the upper side of that particular diagonal of the confusion matrix, and we have to use the minimum cost. So we have to choose E1 with the E4, that is the minimum cost. So first we have to use E1, E4, then E2 with the E3, we have to choose the minimum cost. So according to this, we have to find the confusion matrix. Our problem statement, there is a set of expert, there is the expert, their performance of the yearly performance, there is a different task T1 to task Tk, and our job is to find the subset of the agent which will be perform that particular task. So task 1 is required 10 steps, so our job is find the 10 expert, best expert to select that particular task. We have to also find the optimized solution from this task. We also find the replaceable agent if any agent leaving from the task with that optimized. So we have to propose the model, that is the highest overall value, which is given the summation of the expert average with the negative shortage from the graph coordinate minus b. How problem will work? If you see the figure 5, there is a 5 number expert, you have to find their average. Their average is 20. Yearly performance. If you have to find the their equivalent distance from the figure 5, E1 with the E4, similarly we have to discuss from last three. We have to get their equivalent distance, minimum equivalent distance, E1 with E4 1, E2 with E3 is 5. So we have to find the minimum distance alpha 1 to alpha 4 with the 9, and then we have to get the overall performance A plus B, that is minus B. So if you have to observe that if there is a negative minimum of the B value, our performance will be increases, or it is a more value, we have to reduce the performance. So if you have to go from this our approach, we have to give the read the data set, we have to find the average element, sort the element with the highest priority, assign that highest average to that particular, then we have to find the remaining expert, and then how many expert we have to require according to task. We have to find the subset of the task, that is this task. We have to find the complex different exploratory decomposition, different number of the possibility tasks. Then we have to choose the best subset of the agent which will be performed that task. This is the approach from the selection of the problem. Next task is from the if any agent will be failed, how we have to replace that particular agent. So if any agent after assigning it want to leave, we have to give the chance to leave, and then we have to find the efficient expert agent from that particular data set. So other agent will be same, we have to just replace that agent with the same skill of the agent. So we have to find again same performance from this agent, subset of agent with the other subset of agent, replaceable agent with their performance, plus there is a B factor, that is the equivalent distance factor confusion matrix, and then we have to again check the subset of element which will be give the overall the maximum value, and then we have to choose that particular subset of the element. So how our algorithm is work, we have to introduce two data set, that is the expert data set and task data set. So expert task will be given T1 to 12 number of expert is required, task 2 is given the expert with their yearly performance, and there is a graph coordinator. So we have to find the graph coordinator. Then we have to find the select the there is the average performance of yearly attend. Then we have to choose the every task with the one agent. So if we say the table 6, task 1 is 10 expert, so we have to select the 1 expert, remaining 9, and now our job is find the task expert 9 expert with the subset of that particular agent. So this we have to perform with the confusion matrix. So if you have to see this table 4, table 5th, we have to find the task 10, that is first task. We have to find the equivalent distance from the all distance, and we have to choose the equivalent distance with the minimum. So we have to find alpha 1 to alpha 9, which will give our value of the B, and our average from E1 to E10. So we get the value C is equal to A minus B, A plus minus B, which will be give the most average value, that is the highest average value. We have to select that one. So now this we have to give on the set of experts task T1. So if you have to conclude this task of expert, we say that if task 1 is finding the value of E1 to E9, that is plain expert, and we have to find the A value plus minus B value. We have to find the overall, there is a C value. If you have to check that particular value, there is a different possibility from S1 to S10 set, and we have to choose the set, subset of the set which will give the maximum value. So in this way, we say that S pi is the maximum value, that is minus 2.44. So we have to choose the subset of S pi which will be assigned from the task 1. So in task 1, minus 2.422 is a subset. We have to assign the task, and this will be assigned with that particular. So we say that E11 to E19, that is this plain expert, we have to select it. Similarly, from T2, we have to find the best possible expert according to the task T4. We know that 5 expert is required, so we have to find the next 5 expert. So if you have to want to remove any expert, so if you have to want to remove the expert from E11 which is assigned from the task T1, we have to find the replacement. So we just replace E11 agent with the other agent. Other expert will be same. So then we say that E44 to E90, this will be same. We have to just replace E11. But how we have to replace the agent? Again, we have to give the overall performance value. That is, again, we have to find this subset with that particular performance, plus there is a equality index, that is a confusion matrix, and we have to find the overall value. Those overall value after replacing the agent, the subset of S pi which give the we say that a different expert is available. So after replacing the that particular agent, we have to find the S pi value. There is different S pi value. So those S pi value, subset of S pi value will give the maximum value. We have to select that particular expert again. So we say that E3 which will give the best expert from that according to our approach. We have to select replace E3 with the E11. Okay, so our task 1 is completed. Similarly, you have to go from the task 2. Task 2 is require the number of expert is 4. So previously we have to select the 40. Now our job is find the 4 expert. So table V4 we have to discuss. We have to find again the all the expert, again find the average of all this, and we have to find the again confusion matrix from all these 4 expert. So we get the here find out the value of average, find out the confusion matrix distance, overall the confusion matrix distance, and we have to find the best possible overall value, that is give the 46.6714, which will be assigned from the S4 set. So we have to select the S4 set, and which include the S4 set. So we have to select that particular task. So in here we say that in the task E5 is previously selected, we have to select the best 4 agent expert from that particular task, and this task we have to get the best overall value. We have to select it. Similarly, we have to find the T3 with this expert. We have to how many expert is required. We have to select that particular task. T4 how many expert is related. From this we have to select that particular task, and T5 we have to select it. We have to find in this way. If you have to say that our algorithm is efficiently schedule the expert, depend on the scheduling. Is my task perform a T2 schedule first, a T1 is first. So we have to apply the scheduling. What types of the team we have to require. Integrated from the football team, we want a attacking team. We have to find the defending team. So accordingly, we have to select the best team from that particular team formation problem. Overall, the conclusion and feature of we have to develop the optimized approach from the team formation with involve efficient division subset of the expert with the priority of the task. Additionally, we also allow the replacement of the agent with the laptop expert to the team formation problem with the schedule. We have to give the highly effective team from the maximum efficiency, and in future of work, we have to apply the different meta-heuristic approach from the same problem with the time scheduling problem also, and from the finding the effective team communication problem with the meta-heuristic algorithm, that is the HI algorithm, GW algorithm. And this problem we can also solve some parallel computing approach with that brute force approach with NP-hard problem, that is parallel shared memory programming, that we say OpenMP, or we say that distributed programming, that is OpenMP MPI program we can solve. Thank you all the experts. Yes, sir. Any question?
It's a very good work indeed. I have no query from my side. Keep it up. It's indeed a good work.
Okay. Thank you, sir. Sir, anyone?
Yeah, no questions. Good presentations.
Okay. Thank you, sir.
Thank you so much, sir. Now, the last presentation we have, the paper ID 9855. The paper title is Integrating Scenes and Text Recognition for Improved Scenes Captions to Assist Visual Impaired. The presenter name is Mr. Narendra Muhal.
Hello everyone. First of all, thank you ICACIS conference for accepting our paper, and thank you for our faculty advisor, Professor Jyoti Madkemna, and thank you for our head of department, of Electronics and Telecommunication Department in VIT Pune, Professor Shripad Bhatlavande sir. Title of our current paper is Integrating Scene and Text Recognition for Improved Scene Caption to Assist Visually Impaired People. Contents of our current presentation are introduction to our project, their research gap, novelty of our project, literature review done for our project, methodology of our project, result and analysis, and its conclusion. And at the last, we have included references. To get introduced with our project, basically our project is image captioning system which can be used for a variety of practical purposes. The domains which our project covers is image search, human-computer interaction, and scene recognition. To utilize one of its applications, we have implemented that system on scene recognition for blind people. The model includes scene recognition using CNN algorithm, and afterwards it does sentence formation using LSTM model. At the last, LSTM and OCR output is concatenated and converted to the speech. Next. Research gaps. Research gaps which we have found out from our literature survey includes lack of OCR. Many of the systems have implemented scene recognition, but they haven't utilized it to the full potential using OCR system. Also, many of them haven't trained their dataset on the local database system, like Indian scene recognition. So, we have done the dataset with context to the Indian systems. Also, we have done a portable system which can be carried by a particular person anywhere, so that the system will be easy to handle and will be more practically applicable. We have trained the predefined dataset in various. We have trained the dataset particular to the Indian country as well as dataset on the other countries. Many of the countries have not done that particularly. Also, the dataset included by other systems are intentionally taken pictures, so which gives less accuracy in terms of real life applications. Next. So, to conclude, what are our novelties of this project? It is basically trained on Indian context dataset with other countries dataset as well. Also, we have used LSTM CNN model along with OCR, which gives more accuracy. Combining LSTM and OCR is helpful for conveying meaningful information. The portable hardware is one of the advantages of our project, which is more practical to get applied by any of the person who requires the scene recognition. Improvised overall results by adding the Indian scenarios. So the accuracy will be more in Indian data set.
To talk about the literature review. So we have mentioned the 6 literature reviews which we have gone through the papers. So the first one is talking about the CNN and the SVM technique used for the labeling of scenes, and the LSTM and RNN technique which has been used for sentence generation. And in the second paper, they have talked about the different features extraction techniques such as HOGs, LQP. HOG basically stands for histogram of gradients, and other feature extraction methods. In the third paper, they have talked about the different approaches, which is basically bottom up and top down approaches to have a image caption recognition. Next slide. In the fourth paper, as you can see, there is a comprehensive survey. In this, they have mentioned the old era to the new era, new eras models, and all of these techniques, like such as the retrieval and template based techniques are the old ones, and the new ones which are using is the CNN and all. So they have mentioned those. And in the 5th and 6th paper, they have talked about the CNN and LSTM. But in the 5th paper, they have differentiated the CNN RNN with the CNN LSTM on the basis of the Flickr 8K dataset, which they have trained on. Next.
We have proposed a system which detects the scene and generates audio output of the specific scene. The methodology has 4 main parts, which includes input caption and image, wherein we train the dataset. Second is the pre-processing on the specific dataset. Third is the encoder-decoder framework, which consists of CNN as the encoder and LSTM as the decoder. Fourth one is integration of OCR with the encoder-decoder framework. Here is a block diagram of the overall working of the system, wherein we first pass an input image to the CNN model, which is further passed on to the LSTM model. Simultaneously, the image is passed on to the OCR model, and filtering of meaningful words from the input image is done with the help of the OCR model. At the end, concatenation of both the outputs from both the models is done, which generates an overall screen scenario description of the image. Next. For the dataset, we have trained the CNN and LSTM model architecture on the Flickr 8K dataset, which consists of 8,000 images. Further, we also went on and collected custom dataset, which consists of 1,000 images, which is related to the Indian subcontinent context. We then also captioned those images with 5 lines each, 5 lines of caption each. for a single image. These data sets were divided in 70 is to 20 is to 10 ratio, where 70 represents training, 20 represents testing, and 10 represents validation of those data sets. Next. The next step is pre-processing on the data set. So in this step, we divide the file, caption file into two parts, the image and the caption. On the caption, we check the punctuation, numerical values, and single character words, and try to remove those from the captions. From the image, we pass the image to the CNN model for feature extraction. Next. The third important part of our methodology is encoder-decoder framework. In encoder-decoder framework, we have two important parts, which is first is encoder and the second is decoder. In our project, we have used convolutional neural networks or CNNs as encoder and RNN, recurrent neural networks based LSTM, which is long short-term memory, as a decoder. So we input our image into encoder, which processes it through various layers, such as pooling layer, and capturing hierarchical visual information and generating a fixed sized representation, which is often called as feature vector. We then pass this feature vector into LSTM, which generates the caption word by word. The fourth important part is the scene text recognition, which we have implemented using OCR. So what we have done is we have extracted the text information which is present in the input image to assist in increasing the quality of the caption which we are generating using our encoder-decoder framework. We have used predefined models, model of Keras, which is based on TensorFlow. The input image which we give to the OCR is of size 224 by 224. So we have put certain restrictions in this model to increase the quality and increase the quality of the words. We have passed them through dictionaries so that no garbage values are passed and only meaningful words get selected. And also we have set a limit of 5 words to reduce or to avoid taking many words from the image, which will also hamper the quality of caption. And finally, we concatenate the caption which we have from the encoder-decoder framework and the words which we get from the scene text recognition. And we finally have a meaningful caption. So here are the evaluation matrices. The first one is a blue, the second one is a blue, third one is a meteor, and the fourth one is rise. And there are different models, several models of the CNN architecture, and the activation methods which we have used was the sigmoid and tanh. So in this, the VG16 was the best with the blue score of 0.491, and efficient net was close to it. Next slide. So in the second part of the result, in the right hand side, there are 2 images which was generated by the OCR, and you can see that the words are getting detected, and after detecting, the concatenation has been done, and the caption generated, you can see below the images. So basically, the model which we have used, the CNN models, the efficient V2L and the VG16 was the best, which has the best blue score and the glue score. Efficient net V7 and VG16 has the best meteors and bright score. The average time taken by the VG16, V7 and V2L was 21 seconds approximately, 29 seconds and 30. But VG16 was the best amongst them as it has the 21 seconds of running time. So to conclude, we have built this model to assist blind people in better recognizing the scenarios which are around them. So our model, which is scene recognition as well as character optical recognition, will concatenate both these things and give a better caption. We have, while training, we have deduced that you need at least minimum 25 images of a certain scenario to train the model for getting caption of good enough quality. We have tested 8 different CNN architectures with LSTM to generate image captions. Upon comparison, as Ben said, BGG performed better over the others, giving a blue score of 0.49 over the 0.489 of efficient net V2L. And the scene text recognition improvised overall performance of the model as it gave the text information in the image. And now these are the references which we have used in the making of this presentation. Other total 40 references are included in the paper. Thank you.
Okay, what is the functionality of pooling layer, max pooling layer?
Sorry, sir.
what is the functionality of pooling layer?
So I said I don't know.
You have used the pooling layer, no? Okay. From where you have taken the data set?
Sir, actually, we have collected the data set from ourselves only. We have taken the pictures of different scenarios in Pune, in India, in Pune, and we have make the data set
So
from there.
have you used some filter over there? Which filters you have used to reduce the noise?
Sir, actually, we have not basically used the filter. We have just gone through the images and we have collected the same images of different, like 25 images per scenarios. Like there is a bus, then there are 25 images of same bus or different buses, and we have captioned those images. We have done the 5 captions for it.
And which feature selections you have used? Feature selection model, which our technique you have used here?
Yes, sir. We have used the CNN architecture for feature extraction, and in CNN there are different architectures like SPG16, mobile net, efficient net, exception, and many more. You can see.
Okay. Thank you.
Thank you, sir. Is there any more question?
Any other questions from anyone's side, please?
Have you gone through Markov model?
No, sir.
No.
No, sir.
Some researchers, they have worked on this field also with the help of Markov model. Have you explored? No?
Yes, sir. They have worked, but we have gone through the latest models, which like you are saying about the hidden Markov model. We have read about it, but we don't go through it because the LSTM and CNN was the latest one. So we have basically gone for the different CNN architectures, and we have done the trial and test and trial errors because the data set was Indian scenarios, and we have done many testings and all.
Sir, we'll check out that one also.
Yes, sir.
Okay.
Okay, thank you so much, sir.
Thank you.
Now, as this is the last presentation, so on the behalf of the 2023 IACIS Organizing Committee, I thank the respected session chair, Dr. Pawan Kumar Singh and Dr. Subrata Sahana for their valuable time and their expertise in a field of robotics and intelligent system, and their motivation to the authors too. I extend my hearty thanks to the authors for their excellent contribution towards their research. I would like to thank my fellow coordinator, Oritro Mukherjee, for helping me proactively for this conference. Now, with the permission of our session chair, I am requesting you to please allow me, can I conclude the session, sir?
Yeah, please.
Okay, so as a conclusion of this, concluding the session of today's international conference, really it is being a pleasure being with you all today. Thank you, all of you, for your patience and your contribution to the International Conference on Advanced Communication and Intelligence System, ICACIS 2023, sponsored by CCIS Springer Nature. I, Dr. Garima Shukla, along with my coordinator, Dr. Sophia Pillai and Mr. Oritro Mukherjee, are feeling honored to be among such a wonderful keynote speakers, session chair, researcher, and individuals. I would like to thank to Dr. Ravindra Shaw, conference chair, and Dr. Sanjoy Das and Dr. Ankush Ghosh to conduct such wonderful emerging technology international conference of Springer Nature. So thank you, all of you, and I wish you a very good evening to you all. And the certificate for all the session chairs and the keynote speakers, presenters, and attendees, you will get your certificate through the email ID. So once again, thank you all of you for your kind cooperation with us. Thank you all.
And it was a pleasure meeting with all the participants and with assistant chair and the coordinator. It was a nice conference, and thank you to one all present over there. Thank you so much. Have a nice day.
Thank you, sir.
Thank you, Pawan sir.
Thank you, ma'am.
Thank you, sir. Thank you, all of you.
Can we leave the meeting now?
Yes, sir.
Thank you.
Thank you so much, sir.
Thank you, sir.
Thank you, madam.
Thank you, sir. Thank you, all of you. Once again, thank you.